学这个背景当中呢，
mati, turn off, yes. All right. Ladies and gentlemen, the international webinar is about to begin. Sikkim proudly presents Indonesia Raya National Anthem, Simeo Colors and Simeo Winning Song, Building the Future.
itu nggak dengar ya?
Emang kita nggak dengar soundnya?
to make a difference, teaching everyone to learn. Through science, health, and technology, we will share our expertise. By promoting knowledge and policies, we can build a better world. Let us take a step for our precious home, making future blessed for the people to grow in a life filled with happiness and grace. Hear us, Savior, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a step for our precious hope, making future blessed for the people to grow in a life filled with happiness and grace. Hear us, Savior, building the future is our legacy. Let us take a step for our precious hope, making future blessed for the people to grow in a life filled with happiness and grace. Hear us, Savior, building the future is our legacy. Building the future is our legacy.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, good morning from Yogyakarta, Indonesia. I hope you are doing well amid the challenges and changes during this pandemic. My name is Lely Dian Puspita and I'm pleased to welcome you today to the international webinar on artificial intelligence in mathematics education. Where is it now and what is the future? Today, the 25th February 2021 through Zoom platform and YouTube channel. And this program is brought to you by the Simeo Regional Center for Kitab in Mathematics and often shortened to SIKIM. SIKIM is one of the Simeo centers located in Yogyakarta and under the Ministry of Education and Cultures of the Republic of Indonesia, which deals with the capacity development of mathematics teachers and education personnel, supervisors, headmasters, and administration staff in Southeast Asia. Before we start the program, I would like to thank you for joining us on Zoom and SIKIM YouTube channel. The Honorable, the Deputy Director for Program and Development, Simeo Secretariat, Thailand, Dr. Wahyudi. Selamat pagi, Bapak. The Honorable Board of Directors and its representatives of 6 Simeo Centers, Indonesia. Thank you, Bapak Ibu, for your support. Then the Honorable invited guests and SIKIM partner institutions. Good morning, Bapak Ibu. Thank you for your support. Prominent keynote speakers, Professor Aramunajam from the Institute of Mathematical Science, India, Ms. Janice Jin from Weidong Cloud Education Group, China, and Dr. Andreas Matt from the non-profit organizations Imaginary, Germany. Good morning from Yogyakarta, Prof. Ramunajam, Ms. Janice, and Dr. Matt. And notable moderators, Dr. Ingriana Lim from Bebras, Indonesia, Dr. Mariam Othman from Simeo Rexam, Malaysia, and Dr. Farida Nur Hasanah from SIKIM, Indonesia. Good morning, Dr. Lim, Dr. Othman, and Dr. Farida. Yes. And of course, esteemed participants from Brunei Darussalam, Cambodia, Finland, French, India, Indonesia, Malaysia, Myanmar, North Macedonia, Peru, the Philippines, Portugal, Saudi Arabia, United Kingdom, Thailand, Turkey, and Vietnam. To open today's program, I would like to welcome the Director of SIKIM to deliver the opening remark and officially open the webinar. Please join me in welcoming Dr. Sumardiono.
Thank you, Ms. Lily. It's okay now? Honorable keynote speakers, Honorable Director of Simeon Center in Indonesia, or their representatives, esteemed invited guests, distinguished participants, ladies and gentlemen. Everywhere, good morning. Assalamualaikum warahmatullahi wabarakatuh. On behalf of the Simeon Regional Center for Kitab in Mathematics, or SIKIM, it's a great pleasure for me to welcome you to our first international webinar in 2021, Artificial Intelligence in Mathematics Education. Where is it now and what is the future? Thank you for taking the time to attend this event. In this priceless moment, I would like to extend my deep appreciation to the distinguished keynote speakers, Professor Ramanujam from the Institute of Mathematical Sciences, India, Ms. Janice Jin from Weidong Cloud Education Groups, China, and Dr. Andreas Matt from Imaginary, Germany. My most profound appreciation also goes to today's moderators, Dr. Mariam Othman from our sister centers in Malaysia, Siameo Rexam, Dr. Ingrani Lim from Brebes, Indonesia, and Dr. Farida Nur Hasana, who is also the Deputy Director for Program of SIKIM. Ladies and gentlemen, I'm pleased to inform you that SIKIM successfully conducted 3 international webinars in 2020. Those events were participated more than 2,000 participants from more than 17 countries worldwide. Therefore, the center would like to thank to all mathematics teachers and educators in Southeast Asia and beyond, Siameo sister centers, and stakeholders for their endless support. Well, ladies and gentlemen, I've read that artificial intelligence has a close relationship with teaching and learning in class. And thus, teachers and artificial intelligence can collaborate accordingly. Artificial intelligence, or AI, refers to a simulation of human intelligence in a programmed machine to think like human and their actions. As quote from CNBC Indonesia News, the purposes of artificial intelligence include learning, reasoning, and perceptions. Artificial intelligence is constantly growing to benefit many industry sectors, including education. As artificial intelligence in the educational field to mature, the hope is that artificial intelligence can help fill needs gaps in learning and teaching and allow schools and teachers to do more than ever before. Therefore, since our students of today will need to work in a future where artificial intelligence is the reality, our teacher must expose students to and use the technology. However, many of us have limited knowledge of artificial intelligence utilizations, particularly in mathematics teaching and learning. And here we are right now. Today, our keynote speakers will deliver and also discuss the artificial intelligence scenes from the mathematics education perspectives. Ladies and gentlemen, as of yesterday, more than 700 registrants from Southeast Asia and beyond have registered for this event. This great interest shows us that educators across the world are in strong needs of enhancing the knowledge in artificial intelligence. Finally, I declare the international webinar, Artificial Intelligence in Mathematics Education, Where is it now and what is the future, officially open. We wish you all a fruitful webinar. Stay safe and healthy. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Bapak, for the enlightening remark and has officially opened the webinar. Ladies and gentlemen, the integration of artificial intelligence in the mathematics classroom has become an exciting issue until today. Either it will have positive or negative impacts on students' learning and their future careers. As an effort to address this issue, SIKIM conducts an international webinar series today, and it is expected that the event will foster the exchange of ideas and strategies for the better integrations of artificial intelligence in mathematics classroom, and to get more information related to what artificial intelligence will offer in the future, especially for mathematics education. Well, ladies and gentlemen, are you ready to begin the keynote address sessions? But before that, allow me to read the webinar protocol. This is the webinar protocols. The webinar is recorded. Participants other than keynote speakers are muted. Participants joining from Zoom and YouTube should fill in the attendance list through the link provided in the Zoom chat box and YouTube descriptions. In the end of this webinar, participants should fill in the evaluation form provided in the Zoom chat box and YouTube descriptions. Kindly check on the Zoom chat box and YouTube descriptions regularly. And an e-certificate will be provided for eligible participants. That was the webinar protocols. Another protocol is for dropping your questions in the Q&A box. Each keynote speaker will present for 40 minutes, followed by 20 minutes Q&A. Q&A sessions for participants joining from Zoom. Participants may leave their questions on the chat box. Selected one participants will be given a chance to ask questions directly. And for the participants joining from YouTube, participants may leave their questions on the link provided in YouTube descriptions. And the last, I have a very good news for you that we have provided giveaways for the lucky winner. All participants have the same chance between participants in the Zoom and YouTube. Here's the easy way to do how to win the giveaway. The first, you just follow our Instagram, SIKIM Instagram at @SimYuKitabInMath. The second, please capture the webinar by taking a screenshot of recording during the webinar and upload them to your Instagram story and mention us at @SimYuKitabInMath. And winners will be announced to SIKIM Instagram feed. Ladies and gentlemen, without any further ado, we will begin the sessions of Professor R. Ramunajam from the Institute of Mathematical Sciences, India, and will be led by the moderator who joined us online today. She is Dr. Ingriana Lim, and Dr. Ingriana Lim, allow me to read your short biography. Dr. Ingriana Lim graduated from Engineering Physics, Bandung. Yes, Dr. Ingriana Lim graduated from Engineering Physics Bandung Institute of Technology and got her doctoral degree from Université de Grenoble of France. From 1977 until 2018, she was a lecturer in Bandung Institute of Technology. In 2009 until 2011, she was a member of National Research Council. In 2007 until 2011, she served as a director for Polytechnic Informatika Delft. Since 2014, she is an assessor member of National Accreditation Board of Higher Education. Now, she also serves as Indonesian Computing Olympiad Team Supervisor and Chairman of Bebras Indonesia. Dr. Ingriana Lim, good morning.
Good morning.
Good morning, and I hand over this platform to you.
Okay. Professor Ramanujam, are you here?
Yes, I'm here. Can you hear me?
Yeah, hello. I'm not a robot. I'm a human being.
Wonderful, wonderful.
Yeah, so 40 years ago, I started my career working at our university computer center with a big computer, 16 kilobyte of memory. And now computers are getting smaller, having gigabyte of memory, more powerful, and even at our fingertips. I never imagined that today's people succeeded in creating artificial intelligence used for various purposes to make life easier, including in education. However, I think technology is only tools. The most important is our teachers, my beloved teachers, hello, and whom human people who create artificial intelligence, and you will create future AI creators from your students today. So let's listen to Professor Ramanujam. I will read his CV. Please show his CV. Thank you. So, Professor Ramanujam got PhD in computer science from Tata Institute of Fundamental Research, Mumbai. A beautiful place. I've been there, Prof. After postdoctoral research at the City University, New York, he has been at the Institute of Mathematical Science, Chennai, where he is currently professor. His research interests are in mathematical logic and theory of computation and their application to theory of distributed system, game theory, and security theory. He is currently on the editorial board of ACM Transaction on computational logic. In 2010, he was elected Lawrence Fellow of the Royal Netherlands Academy of Science. Currently, he is Vice President of the Mathematics Teachers Association of India and is on the Education Committee of ACM India and Association for Symbolic Logic. For our teacher, ACM is a notable organization, the most prestigious organization in computer sector, born on 1947 and now having 78,000 members. So please, Professor Ramanujam, please enlighten us with your idea about AI in math and education. Time is yours.
Thank you. Thank you so much. Good morning. Salam alaikum. It's a great pleasure for me to be here to join you on this international webinar. I was in Bandung Institute of Technology in 2016 and in Jakarta as well, and in Bali, had the great pleasure of interacting with mathematicians and mathematics educators and the beloved community of mathematics teachers. And so it's a pleasure, especially for me, to return to Indonesia through this webinar mode. And I hope I'll see beautiful Yogyakarta.
Yep.
Is it okay? Okay. Yeah. So I have given the title for this talk as AI for School Mathematics, Old Challenges, New Prospects. To emphasize, so first, I thank CKIM for the opportunity to speak in this webinar. If you have questions and comments for which we have no time today, please write to me. My email address is here. My Gmail is extremely easy to remember, so you can make use of that. And that the other one is my professional address, but you're welcome to write to me anytime. Okay, so let me begin with a quote. And this is from a book that I would recommend to all mathematics educators and teachers, Paul Halmos in 1965, saying, "I want to be a mathematician." And Halmos is one of the great mathematicians as well as mathematics teachers. And he's talking about how to read a math book, right? Even when you read a textbook, he says, don't just read it, fight it, right? Okay, engage with it. Ask your own questions, look for your own examples, discover your own proofs. Ask, is the hypothesis necessary? Is the converse true? What happens in the classical special case? What about the degenerate cases? Where does a proof use the hypothesis? He says this should be a habit for you. If you want to become a mathematician, if you want to do any mathematics at all, these should become habits of thought. And this is the central thing. Now, what has that got to do with artificial intelligence and mathematics education, right? Bear with me. I think what I want to focus on is mathematical thinking and thinking during mathematics learning and mathematics teaching, and what is the role of that, and what's the role of interaction, what's the role of engagement, and what does technology mean in this context, and especially when you are talking about the technology like artificial intelligence. So let me begin with a little episode, little story. This is long ago. Much of my interest in mathematics education came from working in different spaces, in adult education, then in children's. But I'm not professionally a mathematics education researcher. I do some research in theoretical computer science, but I was doing a lot of school class observations and interacting with school teachers and school children. And one of them was a middle school class, and in which the teacher was explaining the BODMAS rule to children. Now, this BODMAS is one of the major themes in middle school. And when she asked, okay, what is 5 plus 3 times 4? Most children answered 32. You hear 5 plus 3 times 4, you say, okay, 5 plus 3 is 8, 8 times 4 is 32. And then the teacher, now this is against the BODMAS, right? Because times gets precedence. You're supposed to say 3 times 4 is 12, and then you add 5, you get 17. The teacher who had been helping the children to learn the use of the calculators the previous week, and this was a very progressive thing at that time, nearly 20 years ago, and trying to get children to use and learn to use, not so much for that. In fact, she was using the calculator for doing some nice explorations for the children. So she said, look, if you use the calculator, and she showed that you get 17, right? And why does the calculator do that? Because, times takes precedence over multiplication, takes precedence over addition, right? And the children clearly understood. It was clear from what we could see. The children, of course, understood that you get different results if you add first and then multiply, or if you multiply first and then add. But it was clear that the children did not understand why times should precede plus. Why should you do first? You said 5 plus 3 times 4, right? Then, you do 5 plus 3 and then times 4. So it's not so much about what the teacher said or what the children said. This interaction that's happening in the class, there is certain engagement. The teacher is engaged with the children are engaged with what's being asked, but there is confusion. Right? Now comes the something that's unforgettable to me. One of the children, Nisha, asked, look, you showed us the calculator can do a lot of clever calculations. Well, why doesn't the calculator know that we would be confused about this? Right? Why does the calculator just do something that we don't do? I thought, she didn't put it in this fashion, right? It was a little child. But this is exactly what she meant. She said, why doesn't the calculator know me, really, right? And it's a very reasonable question for a child to ask. Why doesn't the textbook know me? Why doesn't the teacher know me? Usually the teacher knows you. Textbook doesn't really know you, right, as a child. A great textbook is one that knows every child that it's talking to. But that's very hard. Now she's asking, what about a calculator? Now somehow she thinks that calculator is a superior being that you're showing me, but it doesn't understand me. And I would like to say that, and this was nearly 20 years ago. At that time, and even today, AI hasn't got around to calculators. So let's be clear about this. When we talk about, very fancy AI, I do not see a simple, calculator talking to children, doing 5 plus 3 times 4 and telling you, hey, do you really mean 5 plus 3 times 4 or, 5 plus 3 times 4? What do you mean? And, knowing whom you're talking to is something that's, considered fundamental in human interaction. That especially if you're a teacher, knowing your children is fundamental. What does AI do in this context? And this is something that I think we should engage with seriously if you want to think about the role of AI in mathematics education. Now, currently AI, or even NI, what is NI? Natural intelligence, often, alas, plays only a small role in mathematics education the world over. So we should mainly speak of the disruptive and transformative potential of AI in mathematics education. In terms of where it is today and where it is headed tomorrow, I do see tremendous potential for it maybe headed tomorrow. But where it is, I think it's mainly disrupting. I mean, there is potential for it to disrupt the status of mathematics education, which needs some shaking up and transformative potential. But then we must ask, what are the central areas of concern with regard to mathematics education? And which are the problems among these that AI could solve? Which are the new problems that AI could create? Right? Let's not be, assuming that AI is going to solve mathematics problems. In the process, it can create new problems as well. And then, what is the dimension that is really unaddressed when we think like this? So this is really what I want to speak on. But first, just as last week, I was having an interaction with mathematics teachers in my region here in Southeast India and Chennai. And I asked, simply because I was talking about this and preparing this talk, I asked about how do they understand AI in education. This is a bunch of very good mathematics teachers. And I found that there is a lot of confusion. Most mathematics teachers seem to equate any tech tool at all with artificial intelligence, right? Now, if I consider something like GeoGebra, there are any number of tools for explanations in calculus. These are very good tech tools, and they're making a significant contribution to mathematics education. But that's not AI, right? Use of any computing technology doesn't make something AI. Like I said, you have very fancy calculators today. That doesn't mean that the calculator is showing AI. AI is much more, very different. Neither is use of big data and machine learning techniques alone. Somebody says, I'm doing a lot of machine learning to this thing. It doesn't in itself make it AI. AI is much broader. What are the symptoms of AI in what you're using? Where is AI coming in? Well, if there is adaptive behavior, if its behavior last month of your program is different from today, right? Depends on the pace at which it can adapt. It shows very different behavior because as it is, it's learning through interaction. That's AI. That's the signature of AI. Conversation. Can it talk to you? Can like that, my intelligent board mass calculator will actually talk to the child and say, hey, do you mean 5 plus 3 times 8? Or, okay, that's AI. Networking. Not that it doesn't act alone. And that, of course, is a very important issue to, enjoy, but also be very cautious about, right? I mean, multiple sensors. AI comes in perception, vision, speech, robotics, moving multiple things, and being part of a large network and talking to each other, learning from each other and building. This is what is making, if you see what is revolutionizing technology through AI today, it's these elements, right? And what are they doing in math education and what is their potential? Now, under development now, in terms of what is AI has accomplished, there isn't much, I would say, relative to, the kind of tech tools that we're talking about. I mean, the impact that GeoGebra can do. Right? Now, there are areas where AI is making some impact now. One is smart content. What is smart content? This is technology that provides typically school textbook content, but in a smarter way. For instance, in helping preparation for exams, right? In terms of helping you navigate the material, in terms of making the question bank that you've got non-rigid. What does that mean? Well, we are used to textbook-based question answering, where the question bank is very rigid. The textbook does offer, your guidebook does offer questions, but there is this, set sequence. And it's very difficult for teachers to escape that sequence, right? I mean, when a teacher engages with textbook in a classroom, I call this the tyranny of the textbook, right? I mean, the textbook takes control of your mind and the way you do, and it's very hard. Smart content gets rid of that. So this is one area where there's a lot of work going on. But it takes curriculum as sacrosanct, syllabus is sacrosanct. Some committee has somewhere made a syllabus, has formulated a textbook. That is mathematics, right? It has very little, this, from whatever I have seen, has almost nothing to do with what Paul Halmos was telling you, where he was saying, fight it, ask questions, Okay, I want to come to that later. But this is one area where there's a lot of work going on. Second is, I've given some examples like content technologies, Jill Watson. I'm just throwing some examples here. I don't even know enough about the technologies and their internals to actually discuss it with you. But these are things that I have seen, which seem to be sophisticated, doing some very interesting ones. I should have added Squirrel AI in this list in smart content. I'll talk about Squirrel AI a little more. And these are basically taking existing mathematical curricular content and providing ways of navigating. The second one, where probably, if you go to AI in education conferences and see what a huge amount of the work, the research, AI research is looking at in education, it is in the second theme, which is personalized tutoring. Customizing whatever you're talking about to the learner's interest, aptitude, and learning style. Now, there is enormous amount of work on this and quite a lot under development. Broadly, AI in education. Related to math education, there is relatively less compared to the overall scheme of things of AI in education, but there is. Now, this is where it gets into really difficult questions. This is something that every teacher faces as a tremendous challenge, right? Now, unlike any other disciplines, mathematics, there is something unique. It doesn't matter whether I'm talking about India or Indonesia, China, or Somalia, whether I'm in East Coast of the US or, Slovenia. There's something that's unique to mathematics. You walk into a classroom of 50, there are 5 children there who do not need you, right? Who take to mathematics like that, and they are with you and they're, ahead and they want more and thirsting for it. And then there are about 15 out of 50 who are very hard to engage with, who are totally disengaged with mathematics and they just want to get out of the whole thing. So much of what we call mathematics education happens in this intermediary, right? For those who are neither those who are, and this is true for anywhere you go. There are always children who take to mathematics. So what's going on? So for teachers, the tremendous challenge is, gauging the students' interests, aptitude, and lastly, learning style. As all educators and teachers know, that every child comes with her own pace of learning, her own style of learning, and especially in mathematics, for those who do mathematics, you ask mathematicians, they'll tell you that, I'm the problem-solving kind, right? I'm not a great theory builder, right? I personally, for instance, do a lot of theory building work. And specific problem solving, I do, and mainly because of my interest in working with education, but my research is mostly theory building. Some people are very good at analytical techniques. Some people are much better with intuitive ones. Some are better in formalization. Some have geometric insight. They prefer geometric insights and visual reasoning. Some prefer analytical ones. There are many, many learning styles. And that's true for perhaps every discipline. I'm specific about mathematics. And when education synchronizes with these learning styles, it progresses much better. But how do we do this in a personalized fashion? And here there is, there are examples like Mika, Pearson, Mastery Learning. There are tools that are available that you can take a look at. There's a lot of work that's going on. And each tries to personalize conversation with the learners in various ways. And you will find problems with all of them, but they're all interesting ones. And I think Sophia also I should have put in here. Yeah. Then virtual facilitators and learning environments. This is access to bots or advisors for advice on specifics and collaborative learning forum. Okay. Now, these sound very simple, but actually they're very, very sophisticated. The idea is that you can go, in fact, Jill Watson, I should have put more into this really, because Jill Watson is really you can talk to Jill for any question that you've got, right? You don't understand limits. I want to know what is limit extending to 0 sin x by x. You ask Jill, and Jill gives some answers. And then you ask more questions, and Jill gives. This is the way it is modeled, right? And the thing is that it's available 24/7. You can go anytime, you can talk. So these are advisors or bots. And I think I would have put Sophia in this list. Yeah, Sophia, for instance, is, okay, I'll come to these later. So, this is the Harvard mathematics team that, a bunch of mathematics teachers who developed Sophia, which is a tool for discussing calculus. In fact, the examples that I gave were from Sophia, not Jill Watson. And, but then the conversation is very stilted. For instance, with Sophia, you ask, is sin x continuous at x equal to 0? And she say yes. And then next question, is it differentiable? She has no idea. What? And then you realize the problem is not that she doesn't know that difference between differentiability and continuity, but you said it, right? You said, is it differentiable? And he doesn't know what it means here. Because the earlier question asked about sin x, and when you ask, is sin x continuous? Sin x continuous at x equal to 0? Yeah. And she answers. Then you ask, is it differentiable? You mean by it, you mean sin x. Okay? Sophia doesn't understand. Okay, this is at least a version that I saw earlier. By now, probably it understands. But my point is, mathematical conversation with bots and advisors is not something trivial. But yeah, there is a lot of this. And collaborative learning where students take up projects together, work on this, discuss them, and makes it, forums that make it possible. And then there are some like third space learning, Duolingo. Duolingo is not so much about math education, it's about translations, managing multiple languages in whatever context that combine some of these aspects. And then there is Imaginary, of which you're going to hear a lot, right? I must say, Andreas Matt is something like a hero, and it's a great pleasure for me to be sharing a platform with him and seeing many of his work, which goes way beyond these in some dimensions, especially in the dimension of visualization, delivering content. I think Imaginary is like a revolution. We're going to hear more on that. Now, so this is a one-slide survey. That's all I'm giving, right? To say that if you look at AI in mathematics education, what is clear right now is there is a zoo out there. There are 100 attempts being made. I'm not sure that they cohere into one vision. Very, very unlikely. And I do not see a particular strand of reasoning and thought. These are the needs of mathematics education, and these are being addressed. In general, education demands, if you take, it doesn't matter whether we are talking about mathematics or, teaching literature or teaching history, you need smart content, right? You need personalized tutoring. You need multiple ways of navigation. You need access to experts who are available. And that's what is going on. Imaginary is highly mathematics focused, but it's like GeoGebra that's mathematics focused, or any of the tools, and it incorporates AI into its tools. But it has a particular vision. So what's the role of AI in mathematics education and yes? And here is Alan Turing, the pioneer, and who as early as 1940 wrote a paper, Can a Machine Think?, which launched artificial intelligence as we understand it today. And Turing suggested that rather than define intelligence, we should ask to certify intelligent behavior. And he suggested the Turing test. Basically, you put somebody in another room, you can't see, you're conversing with that person. And if you can't make out whether the person, after sufficient duration, after sufficient experimentation, interaction, if you cannot make out whether that person is a computer or a human being, that computer passes the intelligence test. This was Turing's suggestion. So it's the test of a machine's ability to examine intelligent behavior equivalent to or indistinguishable from that of a human being. So my question is, what would be a Turing test for mathematics education, right? You have something inside and you're talking to. Is that person a human being? And we are talking in the context of mathematics education as a mathematics learner or as a mathematics teacher. Well, one thing you can ask as a learner, can a machine solve routine calculus problems formulated in common language? Right? Okay. Then this is one question, one test that you might apply. Another test, I think this is what most teachers would say, a secondary school teacher will say, can a machine work with the differentiated needs of 40 students in grade 9 and ensure outcomes in algebra demanded by the curriculum? Then I'll say, okay, it's intelligent. So let me make it clear. I am not advocating these questions. I'm not saying these are the questions, this is the Turing test for mathematics education. But my point is, these questions, the Turing test for mathematics education should be articulated by the mathematics education community, not computer science guys, not technology guys, not AI guys, right? Because this is the demand that you make of the technology. Pointing out that we need clarity on what we want from AI in mathematics education. I think that clarity coming from the math education community, I think is very critical in how we want to drive AI to address the needs. What are the needs? Now, what are the central concerns, central areas of concern in mathematics education? Let me take something from National Curriculum Framework 2005 from India. I was part of this exercise. And, I in fact chaired the National Focus Group on Teaching and Mathematics for the curriculum framework at that time. And it lists the following central areas of concern. First, a sense of fear and failure regarding mathematics among the majority of children. A curriculum that disappoints both a talented minority as well as the non-participating majority at the same time. Why? Because the curriculum is not challenging enough for those who are thirsty and want to go. And on the other hand, for those who, there is a silent majority which is refusing to engage with it at all. And then crude methods of assessment that encourage perception of mathematics as mechanical computation, simply application of procedure again and again. And I have seen this, enormously, especially in India and China and where I have interacted with teachers, and to some extent a little bit in Indonesia also. So, lack of teacher preparation and support in both content and pedagogy of mathematics. Very often, especially in India, the only resource, the educational resource that the mathematics teacher has is the mathematics textbook, nothing else, right? So, and there is a tremendous problem with content knowledge and pedagogical knowledge. And after 15 years, right now, I do not see any need to edit this list. These are the central concerns of mathematics education that I would put in today as well. Now, out of these, what can AI address and what are the problems that AI can solve for us? Well, firstly, I would say this, big issue, I would call it the elephant in the room. It's acknowledged the world over that poor performance in mathematics leads to poor self-image and self-esteem issues among a large number of teenagers, right? I mean, it doesn't come easy for a teenager to say, mathematics is not for me, I'm completely outside. Now, according to the UN, the population of adolescents in the world is around 1.2 billion. We can easily estimate that the self-esteem issues referred to, here apply to at least 200 million adolescents. These are not small numbers, my friends, right? This is a huge issue. Can AI help us solve this problem? I would say this is, central problem of mathematics education. How can we accept something that, alienates a huge number of children. Whatever be the reasons, whatever be the practice. Here's an experience that I want to mention. I've been teaching, typically mathematical logic at Zhejiang University and Beijing for some time. And in fact, just concluded one lecture series in Zhejiang University recently. And I spent the spring of 2019 in beautiful Hangzhou. And I met a student who was taking Squirrel AI math classes. And through him, his tutor, this was actually the brother of one of my students at the university. And the student felt, nephew or cousin, I don't know the exact relationship. Yeah. Now, the student felt that his chances of doing well in the national Gaokao exam would be much better with these classes. And so I actually had a chance to go look at what they were doing. And I was astonished, talk of smart content in this. Squirrel breaks up the curriculum into many small elements and offers intense practice in each in a personalized way and follows a kind of a concept graph to navigate the elements. So it really allows you multiple pathways to work through this. And the numbers are not small. When I say small elements, it's not something that human beings can do. This is really the advantage of AI. It breaks up middle school mathematics into more than 100,000 interconnected atomic elements. Tremendous. And, as teaching to the test goes, this is spectacularly successful. If you have a particular curricular goal in mind, if you have a particular, like in this case, I'm not sure whether they do it for Gaokao, but I don't know. I'm just saying that they do it for the national exams. And I think it's spectacularly successful. And I've seen, 20,000 centers. The numbers are enormous of the number of children. And I saw a video where, which I thought was terribly tragic to me. It was not funny at all. To see, online, there is a teacher sitting there and, the squirrel is performing and the squirrel performs always better than the teacher in predicting what answers children would give. And which I thought was not funny. But in any case, right? Now, these are the kind of systems that we are going to look at, right? And AI can deliver, things of this kind. But once again, let me caution and think about Halmos. What Halmos says, your mathematics education is about. Mathematics is about thinking. It is not about performing to a particular goal, enacting exercises to a drill that somebody sets for you. That's not. Of course, a whole lot of skill building is about this. George Polya, one of the greatest educators, talks about direct application and drill. But that's one among the 4 dimensions in problem solving that he talks about. So we should be very careful about, if I say that anxiety is a central issue in mathematics education, can personalized tutoring, which I said is one of the strengths of AI, can it help in overcoming anxiety? AI can surely help in breaking what I call the tyranny of the textbook, right? The textbook that takes control of our minds, right? Of the children, of the teachers, making you go through exactly one sequence. And if you miss that, you are in trouble. And you are usually in trouble. And especially in mathematics, where the curriculum is shaped like a tall, spindly tower, right? If you do badly in decimals, you have a problem with algebra, then that will lead to problems in geometry. And if you have problems in both, you can't get into trigonometry. And if you cannot do this well, you have problems in calculus and you are doomed, right? No, this kind of thing. So, and there, AI can surely help in breaking this tyranny. We can offer multiple ways of navigating textbook content. Like I said, Squirrel, I think, is dramatic for me in what the possibilities. We can make room for multiple learning styles, which I've not seen too much of, but at least 1 or 2 like content technologies do show some possibility of that. And like I said about Sophia, Jill, right? Chatting with a bot can be frustrating, but still perhaps maybe less intimidating than a mathematics exam seems to do for children. Right? So these are, but then the dimension where I think AI can make a tremendous difference, and I do not see enough happening on that, is for inclusion in math education. AI can play an entirely transformative role in mathematics for children with disabilities, for visual impairment, right? Where tactile techniques currently used are pathetic, right, in terms of what is possible, right? Especially for geometry, for algebra. Right? They can be dramatically improved using it. Children with motor disabilities, children with learning disabilities. Personalized content can be the greatest boon that we can provide for children with multiple disabilities. And this is an area where I see, not even a tenth of the kind of work that is needed. And then for bridging content, okay, when children drop out of the system and rejoin for a variety of reasons, maybe you broke your leg while playing football, right? Could be any kind of reason. Or in India or in poor countries in Asia, we know, people, children go to help their parents and harvest in rural areas. Any number of things, And a sequential discipline like mathematics makes often difficult demands on them. 1 month, if you miss classes, you are in trouble. And if you drop out and rejoin. Now, so AI can really help bridging content in many ways, right? I mean, I learned something in grade 8 and I've forgotten. And I come to grade 9, how do I revisit? And these things AI can. So differentiated pace of learning is something that AI can help. Again, don't ask me for which tool does it best. I don't see it yet. But I'm saying these are the demands we need to meet. What about the new problems that AI may create? We need to be very cautious about personalized content and tutoring. I'm very wary of, censors looking at children closely, all the time. And in fact, looking at them much deeper than teachers actually do. The effect of these things we don't know yet, and I think we should be very cautious in that. Large databases that store enormous amount of information, personalized information on children. I think society doesn't know anything about how to deal with these things yet. So we need to be, and we know that algorithms can reinforce biases and can lead you into a well from which it's very hard to climb out, right? Because it thinks that this is what you are, and it pushes you into looking at more and more content, which reinforces it. And at that point, children's things are all evolving, are shaping, and then you get pushed into one style. This is a tremendous problem, and I do not see AI addressing it sufficiently. So I would say these are caution. In the case of children, we should not, when AI research talks so much about personalizing based on interest and learning style, it sounds very good. But I think, with children, you don't look at their interest and style. You have to look at their potential. You have to see where they should go. You want to see how to shape them. And I worry that algorithms may end up limiting their potential by overstructuring, which we already do in our mathematics classroom. We limit the children's potential enormously. Algorithms can do it 10 times more, at least. I don't know, maybe 1,000 times more.
Dear Prof, sorry, you have 8 minutes
Thank you.
left. Okay, thank you. Sorry.
Technology is seductive and addictive, and hence may work against critical thinking. And I think this is the other major problem with technology. Technology is very seductive for children. And and of course, children may expect computers to know everything, solve all problems, and that's a grave danger. Like as it is, that's happening already with children growing up now. This can become much worse as we go along. And then, while computer-aided instruction has been a major theme in research, the use of AI for strengthening teaching seems to be much less explored. Almost all the tools listed above work directly with children. Much of my caution applies to that. But on the other hand, a good model for AI and teacher collaboration is yet to come, but it can hold great promise for mathematics education. Now, AI can help the teacher in integrating the variety of visualization tools, computer algebra systems, banks of graded problems, and concept maps into actually classroom activity based on processes and mathematics. And, let me see, look at this. You ask, evaluate x squared minus 1 by x minus 1 at x equal to 1. You can't do that because that's division by 0. Then you say, evaluate limit extending to 1, x squared minus 1 by x minus 1. You can't do that. It's x plus 1. Evaluate the limits, it's 2. Now, it's not a matter of an AI system being able to solve these problems correctly. It's a matter of understanding the student's confusion and the teacher's plight in negotiating the terrain. Both look very similar and are very different, and students have enormous confusion, and teachers have enormous problem. So the role of context, right? Take something like a variable. right? A variable denotes unknown numbers. When I say x plus y equal to, x plus 3 equal to 5, it's a single unknown number. When I say x plus y equal to 5, natural numbers, it can take certain possible values. When I write x plus y equals y plus x, it can be any number whatsoever. And then we write, consider the line where x equal to k, where k is a constant which can be any number. Right? Now, mathematical communication is, rich with multiple meanings. For instance, if I ask what is a polynomial, we ask students to factor and expand them, so they are expressions. We ask students to graph them, so they are functions. We ask students to find their roots, so they are equations. The mathematical answer is that it's neither an expression nor a function. It's an element of a ring, and it has many expressions for it. The pedagogical answer is it's both an expression and function, depending on the context and the level of the student. How can AI deal with these things? Should. And I think we, as math educators, we must demand, these are the questions that AI should look at in mathematics education. Gamification is a term, gaining currency, but unfortunately, mathematical content is rather thin. Most of them have a lot of bells and whistles, beautiful graphics, and immersive thing, but the math content is rather weak from what I have seen. Digital Destination is a game that I saw, which, lets you experience coordinate geometry. Then there are pursuit problems, lots of such games. One of the best examples that I have seen is this Ramanujan machine. That is mathematical thinking. It offers conjectures for you, right? You can play around, offering partial proof, suggest algorithms, modify conjectures, etc. This is pretty much the kind of engagement that if a new theorem or algorithm comes out of it, it's in fact named after you. Here's an example. These are conjectures offered by the Ramanujan machine on continued fractions. And people have engaged with it. And these are now theorems proved by people based on conjectures made by the machine. It's a classic, it's perhaps one of the best examples that I've seen of man-AI, human-AI collaboration in mathematics for mathematical discovery. And it's possible to personalize it at different levels. So doing mathematics means many things. Selecting between representations, looking for invariances, observing extreme cases, and typical ones to come up with conjectures, looking for counterexamples, simplifying or generalizing problems, most importantly, building on answers to generate new questions. AI can help the teacher in this, not so much the student, to select and enable these in the classroom. Mathematization involves a range of processes: abstraction, representation, use of patterns, visualization, use of heuristics, estimation, approximation, formal communication. This is an excellent wish list that we can give to AI researchers in education. Show us how we can build these into the mathematics classroom, which we find difficult right now. Last words, here is a quotation from Leon Henkin, where he says, one of the big apprehensions about mathematics that we perpetrate in our classrooms is that the teacher always seems to know the answer to any problem that is discussed. This gives the students the idea that there is a book somewhere with all the right answers to all the interesting questions, and the teachers know these answers. And if one could get hold of the book, one would have everything settled. This is so unlike the true nature of mathematics. Henkin was a great mathematician. Now, with Google and AI coming into the mathematics classroom, that warning should ring louder in us. Thank you very much. Questions, comments, welcome, and you can always
Thank you very much. It is very interesting. I think our teacher have a good idea about how to integrate AI and then small bite-sized materials, and math can be very interesting. I saw your machine. It's really amazing. I hope after this one, they can look at your machine and contribute to algorithm to you. And now we come,
Not my machine, it's just named after mathematician Ramanujan.
Yeah, it's a pity that you don't have time for demonstrating your very interesting visualization and machine. Now we come to the question and answer. Can I show the question, please?
I'll stop sharing.
So, because of the time, we can only choose one question from each category. But I make a resume of all questions. Maybe they can you can answer by email.
Yes.
So the question from Zoom is the first one. I think the first one, could you give example activity to encourage students learn mathematics through AI? This is very interesting.
Yes, I think the one that I have personally, engaged with and seen most is in simplification of algebraic expressions. Okay, where this personalized content, I've seen how what it does is basically it tries to figure out. No, in simplification of algebraic expressions, we give a lot of rules. What are the kind of rules? Group like terms. Bring all things of the same term of the same degree to one side, and usually to the left hand side to these. Right now, unlike this, what the AI system does is actually sees what strategies you used in the earlier examples that you have done. What it does is it offers you those expressions. So it's basically the same thing like what you do in class, but rather than giving a bunch of undifferentiated expressions for children to simplify, what it does is it has a whole bunch of expressions, but it also has a whole bunch of strategies that you used. It observes and finds out. And then what it offers is, it has a concept graph in terms of levels of difficulty. And what it does is, okay, the next one, it gives you sufficient examples so that the strategy that you use is reinforced. Or if you've been doing something incorrectly, you have an opportunity to find out, make more mistakes and find out in that. And then once you reach a certain, and that is, it calculates a certain factor. I think I've forgotten, it's something like 0.75 or 0.8 in effectiveness of your strategy. And then it moves to the next level. So basically, it has got a whole bunch of problems that for the child to solve, especially in something like this algebraic simplification. And it just lets you navigate through them in a very, in a personalized level. This is one example activity that I've seen. Then in games, there are enormous number of games, and games which let you navigate, like the one that I said, a game that allows you to experience coordinate geometry by letting you move around. For instance, if you're doing it on the plane, it lets you move around in particular ways. And like in pursuit problems, you see you're the cop and the robber is going, and you're given a lot of information about the relative speeds, direction, etc. And you have to calculate and pursue. So that's another way by which, by playing the game, you learn navigation in R2.
Thank you. And now the second question from Srido. The question is from the YouTube. You will be very famous in Indonesia. How to integrate AI in the textbook? This is the question.
I think, this is an interesting and a difficult question for a variety of reasons. Now, I have been involved in mathematics textbook preparation, not so much as a writer, but as a person helping textbook writers and reviewing them, etc. Now, the textbook suffers from several problems. One is that there is, you can't have a textbook that's 1,000 pages, right?
Yeah.
You should not have. There must be a law which says that, textbooks is something that children can hold in their hands comfortably, and that's all. So you have page restriction, size restriction. And then you want it to be in color. You want it to have lots of pictures, but then the more color you want, the more stories you want, the more boxes you want, the textbook is becoming bigger and bigger, right? Now, this is a problem that AI can solve by changing the shape of the textbook. And another problem that, when you go to digital content, there is no problem with that. You can go into, you can also go into presentation mode where you visualize the whole topic using a concept map. And then by clicking on and by, navigating the concept map, you can navigate content in different ways. And another very, very important way in which AI can come into the textbook is by integrating your textbook content with, for instance, visualization tools, computer algebra systems. In India, I have seen this effort to integrate textbooks with GeoGebra, and where I've already seen the tremendous potential of that. That the idea is that every expression every algebraic expression that you see in the textbook is clickable. If you click on that, you get a window where you see the graph of as a function. Now, if you take a cubic polynomial, and if I ask you, if I double the coefficient for degree 2, how will the curve change? Now, this is something that you can talk to the most sophisticated mathematicians; they cannot tell. GeoGebra can show you in 10 seconds, right? Or if you pull the curve down, how the coefficients change. Now, this is simply a visualization tool. There isn't much, in terms of AI in that. But my point is, when you also have personalized content, when you have these multiple navigational pathways, I think the shape of the textbook, the structure of the textbook, and the way we navigate material, present content, all this can change dramatically. So this is one thing where it can. But then it has tremendous limitations due to technology. It means technology access. It means equality of technology access. All this we are very, very far from, especially in India, and I'm sure in Indonesia as well. So, but I think the potential is there, is what I would say.
Okay, thank you very much. And the last question from the one, the organizer. Can you please give unmute to the first person who raised hand? Please. Juster Tarigan. Oh, I can do it. Please, Juster Tarigan. Hello, the organizer. Can you give Juster Tarigan, please? No? She is not there. Hello. So the second, Nur Rafni. Are you there? Oh, no. Rizky Adila. Nur Rafni, are you there?
Yes.
Please express your question.
Okay, actually this topic is very interesting, and in my country, Indonesia, actually I'm from Jakarta. Hello for everyone. Hello for Prof. The question is how to implement this AI into the learning. That's my question.
Into classroom learning, I think, yeah? Yeah. So, yes. I think, AI can, like I talked about, AI can deconstruct and reconstruct the textbook for you. It can also deconstruct and reconstruct the classroom space, right? Right now, what is the classroom space that we look at, right? The classroom is one where, it's not just a space for, mathematics or learning, right? It's a space for children to come together. Children interact with each other, they have social processes, and then the teacher placed in that is part of the social processes, and mathematics education happens in that. And now, if you want a class where, there are 6 groups of children working on different problems, or, different problems on the same theme that you are doing, it's not easy to do, right? And if they are also using devices, for instance, like I said, GeoGebra, right? For instance, you are doing conic sections. Right? There are many ways to do conic sections. And every student, not every student, you will find.
Nggak ada, Bu.
Yang masuk Mbak. Masuk di itu pada selangkah.
Yeah, you would find that, there are at least 4 or 5 strategies that children use to understand class. Now, how do I let all of them happen and go through them and actually give comment and feedback? This is not easy at all. And this is a problem that is there from primary school all the way to higher secondary school. And with primary, it's even harder because with children screaming and saying, me, look at me, right? And multiplication, right, or division, there is not one way, and there are children going to primary and different things. Now, and there, I think the role of, this kind of technology, with all the cautions that I said, I'm always uncertain about, technology in the hands of children, which they this thing, and technology observing children, all that. But in the hands, if we come up with good, ways of regulating it and maintaining that, I think this can be a wonderful tool for the teacher, right? Because children can then, what they are, if you take any particular example, right, like I said, the conic sections, this comes easy to me, so I'm saying with secondary mathematics. But in primary mathematics, we can think of, right? Fractions, the typical thing that all maths teachers at primary level, tomes and tomes keep getting written on it, and we have problems, right? Now, there are any number of activities, right? There are many activities that we do with fractions, something with continuous one, where you take something like a piece of bread and Indian, you fold it and do circular ones in different shapes and then discrete ones where you count and make fractions, right? 1/3 of these or whatever, and they can be doing different things. And how are you going to watch what is going on here and see that Isha in that corner is not responding at all, and this one is dominating? How are you going to do all of that? And there, as I said, if done in a positive way by encouraging all those learning styles, all those spaces for their differentiation, AI can be a tremendous boon because it brings the ability to observe, intervene in real time for many children, and not only those who are present, also the Mohan who is sick and sitting at home and participating online, right? And you can still you can have a class with all that. Now, these, I think, that's true in general with education, but in mathematics, especially where participation is so important, engagement is so important because of anxiety and worry and self-confidence issues. I think it can. But I must repeat that all these, we are talking about something very new for which we do not have social control. We do not understand it in social terms yet. And that's why let me end with once again this thing that the assessment of AI in mathematics education should come from mathematics education, right? AI itself is seductive. We cannot afford to leave it in the hands of the, computer science guys and the technology guys and the geeks and, these are it's the education community that should take the lead in saying, this is what we need. These are our central problems. Because if AI comes and solves some of the peripheral problems and does not attack the central ones, the status of mathematics education, like I said, this 250 million alienated will continue. So that has to be our priority. Thank you.
Okay. Thank you very much. So we come to conclusion that I think the teachers should not worrying that AI will replace them. AI will help them to be a better teachers, will assist them. So please give your concluding remark for closing your session. Thank you. Please.
The concluding remark is mainly that, we have the title, let me recall the title again. I said old challenges and new prospects, because the challenge that I placed is perhaps the oldest challenge. That is that there is this huge number of, students, teenagers with self-esteem issues related to mathematics. And that's, as I said, we are talking about 250 million. If that is not a central issue, what is a central issue? Right? Mm-hmm. That any number of our children sitting in our classrooms, feeling alienated and saying, mathematics doesn't come to me, right? So that, I think. And then there are these tremendously talented ones for whom we're not providing enough mathematical opportunity and bringing mathematical thinking and critical thinking and engagement into the classroom, right? These are the main ones. Whether AI can help us solve these problems or not, we must drive AI towards solving these problems. And a whole lot of problems it can solve, but, with the math education community, that should take the lead in this. Thank you.
Thank you, Prof. Thank you very much. Keep in touch with us. I hope that will not be the last one. We can have a conference together. Thank you so much, and I give to the MC now. Thank you. Let's give applause.
Assalamu alaikum. Thank you.
Manager for the insightful presentations, and Dr. Ingrid Lim, thank you very much for the cheerful spirit you have brought to us in leading the sessions. Please once again give a round of applause for the amazing presentations and discussion. Thank you. And ladies and gentlemen, apologize for the technical error that happened, but believe me, we always try to give you the best, and it doesn't hinder our enthusiasm to take part in this webinar for the next 2 hours. Do you agree with me, right? All right. Please remain on your seat. Don't miss any second for this fruitful international webinar, because we still have keynote speakers 2 and 3. Ladies and gentlemen, together we will hear the presentations from Ms. Janice Jin from Weidong Cloud Education Group, China, and will be led by the moderator who joined us online today from one of Sikim's sister center, that is Simeo Rexam, Malaysia. Allow me to read the short biography of our second moderator. She is Dr. Mariam Othman, the Deputy Director Research and Development at Simeo Rexam, Penang, Malaysia. She completed her PhD in 2010 from School of Education, University of Manchester, United Kingdom, in Measurement and Statistics in Education. Previously, she served at Educational Research and Planning Divisions, Ministry of Education, Malaysia, for more than a decade, specializing in educational forecasting for Malaysian government schools. She is also the chief editor for a Journal of Science and Mathematics Education in Southeast Asia. She has facilitated in workshops on integrating robotics in STEM education for teachers, educators, and students. At present, she and her team are involved in developing teaching modules in cooperating socio-scientific issues and global citizenship. Good morning from Yogyakarta, Dr. Mariam Othman.
Good morning, Miss Lely.
Yes, thank you. And I hand over the platform to you.
Okay, thank you, Miss Lely. Thank you for the introduction. Okay, Assalamualaikum and a very good afternoon to everyone. Okay, now we will move on to the second session with Miss Janice Jin from Weidong Cloud Education Group. Okay, a brief biodata about Miss Janice. Miss Janice Jin has been the Vice President of Weidong Cloud Education Group since 2015. Okay, she holds a Bachelor and Master in Business Administration from UPSI University, which is University College Sedaya International University, Malaysia, and Brest Business School, France. Her interest areas mainly focus on sales and marketing, especially in key account solution sales and go-to-market. Janice is also familiar with ICT-based educational solutions for educational institutions. She has managed long-term strategic partners of UNESCO and Simeo in ICT and artificial intelligence. Okay, without further ado, please welcome Miss Janice. Okay, Miss Janice, the screen is yours.
Hi. Good morning. Good afternoon, actually. Yes, dear district leaders and Simeo high officials, colleagues, and peers. I am Janice Lin, and Vice President of Wheaton Cloud Education Group on the occasion of Chinese New Year. And I would like to take these opportunities to thank you for your unwavering support and partnership over the years. Your contribution and dedication have made all of Wheaton Cloud Education Group's achievement possible. So now I'm going to sharing my screen to let you guys to, can you see my screen?
Yes.
Can you see my screen?
Yes, very clear.
Okay, yes.
Thank you. So first page of my PPT is a very shortly introduction about Wheaton Cloud Education. Wheaton Cloud Education is an international education group who provides comprehensive solution of digital transformation in education for educational institutions and public departments around the globe, and one of the strategic partner of UNESCO and Simeo in the field of ICT and artificial intelligence. And for our solution and services, I go into very good, shortly introduction about the WLMS and financial support and the content, and also infrastructure, computing services, and networking. Next page about our infrastructure is it is the main services for Africa and Asia countries. For example, the computing the Africa countries service in networking and devices like big data center and the smart classroom. For the learning management system, which supports formal and informal learning in both public and private sectors, available in English, French, and Russian versions. It is applicable for all of the level of education, including K-12 higher education and vocational training. The main functions include teaching, content, production, and organization daily activities management for teachers and students. This is the main features about WLMS, like live streaming, performance analysis, quiz, and multimedia playback, and the calendar. And another short introduction about our vocational group in Paris, French. This is the good vocational education group resources integration solution provider, owning 8,000 teachers staff and 800 world top industry experts, education experts, curriculum expert, and platform technical from European and American developed countries. It has training over 308,000 medium and high-level company staff and more than 2 million global online curriculum users. Another one is our higher education part. One school from Paris is a BBI business schools. Founded in 1982, the BBI schools is provide over digital and online courses with three exclusive master: logistics, finance, and internal control. And another one is training program and content. This is also for vocational part, like the program management training program, is provide 8 companies from different industries around the world have already successfully trained 165,000 project managers in deep collaboration with 80 famous schools in 13 European countries, offering entry-level or professional project manager training to achieve students and graduates. So I'm going to sharing a video to let you guys to learn what the artificial intelligence technologies, what we can learn and what we can offer into South Asia countries. This is my colleague, Emily, and also one colleague, Olivia, who is in Qingdao, China now, and give you one good introduction for our artificial intelligence. What's wrong? Let's try again. Okay. I think the Wi-Fi system not good. It's okay. Now I'm going to introduce by myself for the education AI programming for the future waivers. This is one good artificial intelligence in technologies in our from Waiton Cloud Education. Future Weaver is a powerful brand under Waiton Cloud Education that focus on offering 17 with solutions for education on AI programming. Dedicated to helping students and teenagers first achieve a deeply understanding of basics of application and programming of AI technologies, and then own AI programs. Okay, this is content about what the introduction of Future Weaver. Okay. Briefly introduction of Future Weaver is with view to development of society and nurturing of talents in AI era. Weaver is a platform for teaching and studying AI programming that draws on the operation of international internet education is rich educational resources and tasks take into consideration the reasoning skills of teenagers and their major interests when learning things based on the combination of visual and combination environment of programming and the intelligent hardware. Okay, for the concept of Future Weaver, this is our vision and our mission, the receipt of success. Actually, the Future Weaver is we have successful cases in Philippines and also in Uzbekistan, and those countries we all give them the free account to let them to join our platform, to let them to try to help teenagers and students easy understanding of AI programming and AI technologies. And following the principle of foreignness, scientifics, system analysis and university, and with the basic concepts, foundation curriculum systems cover the beginning countries on programming and beginners, intermediate and advanced courses on AI. I'm going to show the next page. Okay. With the latest AI hardware application that exerts the widest influence on the society and the environment for practice, Future River is committed to helping students complete the entry journey of learning from perception, cognition, practice through the innovation. And Future River is adopts a progressively project-based curriculum system that covers aspects related to AI, such thinking, and evolves learning journey divided into 3 stages, including the perception, cognition, and the innovation of intelligence, with the aim of helping kids and teenagers. Okay, next page. Teenagers, we have to complete the learning of knowledge on AI programming progress from the easy level to the completed one. So this is course planning. Also, we can customize for each schools or each countries to give them a customized right to let them to planning the course and content. And the elementary and middle school students can make AI application programming through graphical programming and publish their products on the intelligence hardware. Those realizing humanized intelligence that capable and of hearing, speaking, reading, observing, writing, and thinking. And all programming software and of the thinking ability and major interests of teenagers, Future River provides an operable and easy to understand AI programming platform with the completed AI and implementation logistics and covers complete source code programming into graphical programming, which is presented in the form of commands, modules, and building blocks. Okay, this is the intelligent hardware for the Future River, like automatic car and the robot and the intelligent robot drones. For the teaching and learning module, outlines self-independence, controllability practically. This is the students and kids, teenagers can following the project-based learning module to control all the steps and planning to solving quickly from a problem during the case study, practice, personality, creation, and the sharing of an all around the impressive learning experience. Okay. Also for the teaching and research team, and the teacher and research team of Future River has a professional background in education technology, which from Google and Huawei, they can make a very professional technology for our Future River, and this is background. Okay, when I'm going to introduction the AI programming for the for the car, automatic cars. When the car starts to work, press the traffic lights so that the traffic lights are in the state of traffic lights. When the car sees the traffic lights, and it will stop. After the traffic lights are over, the car continues to drive along the middle black lines. And actually, I want to play a video, but I think the Wi-Fi system cannot play video, so I just using this PDF. I'm sorry for that. Okay, when the car see the stop sign remove the person who control that, and they remove or black the stop sign, the car will continue to drive. When the car reach the intersection, the car will turn right automatically and drive along in the parking road. Okay, but also they can automatically parking using our AI technologies. When the car arrives the parking area and see the P sign of the parking lot, and the car automatically adjusts the camera to recognize the parking space. If the parking space is occupied, the car will continue to search for the parking space. If the parking space is empty, the car will adjust the body and start automatically parking into the big black line in dedicated, and then stop. This is really interesting, right? Okay. Next is maybe I can sharing later to the chat box to let you guys to learn the future rivers. Okay, now I'm going back. This is the corporate owners for our future river. Okay, so now I'm going back to my PPT. For next part of the what we can help South Asia countries partnership. Actually, it's really good services for that. Because I have 8 year experience for the international market. My clients and partnership also have really difficult reasons for the financial support. So for this support, WeDong is offering very special to South Asia countries and Africa countries. For this special offer, we have 3 different parts. One part is WeDong Cloud Education Group. Another part is Part B, cooperation countries, like institutions and company, and another part is cooperation institution. So for this special offer, what we have several advantages. For example, is competitive rate, only 2% and 3% loans for 15 years. And 2 is go up to 15%. And cooperative banks, China policy banks and global commercial banks. And insurance is China Centers and timelines delivery quality digital education solution in time, shorten the time of GTM and quality assurance. And that means if our partnership or cooperation partners who have the questions or budget problem, we can using this solution to help them, and easy to get the good solution to help schools, kids, to let them to learn the good resources, education resources as soon as possible, and no need to pay very shortly. They can pay into 15 years as per years. Okay, for the coronavirus time, what we don't help the students and South Asia countries. I'm going to very shortly introduction. Since the outbreak coronavirus, Weidong Cloud Education has provided remote class distance learning solutions for nearly 10,000 educational schools in China, with more than 10 million users, and teachers and the students are using We Learning Management System to realize remote teaching and learning. This is the practice in coronavirus time. And another very relevant action through cooperation with UNESCO is the Weidong Smart Classroom, which is integrated with digital devices and an online learning platform that has successfully implemented in University of Pakistan, Uzbekistan, Egypt, and also another Asian and African countries, and helped teacher and students facilitate learning during periods of school closure. And the future school project of UNESCO IITE will also be implemented in several Asian and African countries with Weidong ICT in education solution to help developing countries improve the ICT capacity and digital development in education, and to help the Uzbekistan, like South Asia countries and Africa countries to solve their problems when the school closures. Okay. So now I'm going to try again for my video, and if it's possible, we cannot. Okay. Loading. To open one. Give me a second. I think it's not possible to open it. Okay, please. Excuse me, can you see the loading loading page? Maybe.
Miss Janice, maybe you could share the URL video.
Hello, Dr. Mariam. I'm sorry the radio is cannot open. I think we can go in next step for our Q&A part, and later if the video can play and we can return to the video.
Okay, so there's a suggestion for you to put the URL video in the YouTube. Okay, we'll proceed with the Q&A if you insist.
Yes, thank you so much.
Okay, have one question so far.
Okay.
Okay, I'll try to share. Okay. Can you see the question?
Yes, I can.
Okay. Question is from Nuri Martini. Okay. Is Wedong Smart Systems friendly user for lower grade, including lower bandwidth? Is it possible for us to connect to our current LMS that we have before, such as Google Classroom? Okay, thank you.
Okay. Thank you for the questions. For the learning management system, our one is actually is these questions are around two different systems. One is learning management system and another smart system. And smart system is one artificial intelligence for future river, and also is learning management system is for students and teacher teaching tools. And connect to Google Classroom, where for learning management we have several advantages. One is we are free for South Asia countries schools and learners, and we have live streaming and rich courses and rich content. Third one is the rich content for South Asia countries, and fifth one is this is customized learning management system. Anyone can give us the request for the learning management system. And another good advantage is now is free for all of interesting persons, and also anyone can upload the contents and the courses to the learning management system to let all the persons who interesting to the courses, let them to see and to learn. And another one is for I think another question difference with is Future River smart class smart system. For our system, we are support provide online and offline technologies. So if the Wi-Fi system is really bad, and also we can give the good using feeling in offline. So anyone, if the problem they have problem for Wi-Fi, internet problem, or really lower speed of internet, they can using our offline learning management system. And another one is to support the correction situation of teaching in the South Asia countries due to non-fixed classrooms. WeDong is willing to provide the content part and the free use of learning platform to South Asia schools and from elementary to the tertiaries, including the K-12, higher education, vocational students and schools, and no time limited. So anyone can join now. So this is my answer.
Okay, thank you, Ms. Janice. Do you want to accept the next question?
Okay.
Okay. Okay, the next one is from Slido YouTube. Question is, does WeDong Cloud Education integrated with other IT solutions and providers? It's from Anonymous.
Okay. Yes, thank you for your questions. For WeDong Cloud Education Integrate, we are using actually using IT technologies, artificial intelligence in like the VR, AR, XR technologies. Later, I will sharing my link to the chat box and to let the guys to learn what we doing for the artificial VR reality and the AR reality solutions. From now, I just give a really introduction for the AR and IT solutions for the like the exciting responses, integrated simulation, and integrated driving and services control solution, and also for the smart public driving for using the IT solutions, and AI programming and the video of future river is using the artificial intelligence solutions, and they can help the lowest resources countries to let them to learn what the latest IT solutions in the world now, and they can give us the good solution and give me feedback, and we can give them to let them to learn what we can give the good solution to the schools. For the XR and VR reality solution in WeDong, and we extended reality platforms ideally suited for wide variety educational applications like XR, VR application for controlled the repeated scenario, rehearing muscle memory and situational awareness. And also VR, XR, AR application make it possible to explore places otherwise inaccessible. And VR, AR application have the potential to provide access to resources that may be prohibitively expensive or otherwise inaccessible. accessible, and also we can give the good innovative ways to visualize and manipulate data, and panic about AR, VR, XR in IT solution. We have several misunderstanding about that, like expensive, including both one-time investment of hardware devices and the continued investment on the content. And second one about content shortage. Out of the box content is not enough, but customized content involves more import and budget and time. And the third one is lack of interactivities, and the virtual reality is rigid and lacks flexibility. It devalues the importance of human connections and synergy in education. And also for the justification and not expertise anymore. The price are dropping dramatically along with the technical maturity, and including hardware devices and content creation. And the creation of contents is much easier than before. It's encouraged from a healthy community to create XR content by the educational professional. And VR is not replacing everything about the current teaching learning model, but doing a complementary role for various areas with noticeable features and performance. Virtual reality is reaching a mature state. The virtual reality was in, I think, a state of shape of in 2017, and it has disappeared in 2018. It's not longer an emerging technology anymore. The VR becomes mature and get employed to solve real problems. And the state about VR is technology is ready and widely applied in various industries. And the concepts of the AR, VR, MR, yes, and also VR. And we have light augmentation, mixed reality, and full virtual environment. Like AR is like augmentation, and the mixed reality is immersion spectrum like MR, and the full virtual environment is VR, and AR is digital content on top of your real world, and MR is digital content interacts with your real world. And VR is digital environment that shut out the real world and full virtual environment. And we don't also is give a good architecture like near eye display and perception and interaction and network transmission and rendering processing and content creation. And this is my introduction about the IT solution we integrated with AI, artificial intelligence. Thank you, Dr. Mariam. Thank you for your question.
Are you for another 2 questions?
Yes, if the time is good for me.
There is still time, unless you want to continue your presentation.
Okay.
Okay, for questions, okay?
Okay, no problem.
Okay. Okay, the next is for the live question. Okay, we are hoping that, hold on, is Mr. Teguh Firmansyah Apriliana is around, so he could ask the live question.
Good, no problem.
Okay, so Mr. Teguh, are you here? Just now you raised your hand. If not, we move on to the next Zoom question.
Okay.
Okay, then we move on to the Zoom question. Oh, sorry, Slido from the YouTube, sorry, from Rosalie. How to apply the courses? Is it open to all or only for the certain countries?
Oh, yeah. Thank you for your question. For the courses and also for the content, is actually we give all the teachers and the owners provided one key password. If the password is open for any for all of one, and the video and courses is public, but if the password is only control from the provider and teachers, so they cannot public to the world. So it depends on the provider, and also but for Weidong Cloud Education, we give several like 100,000 like that around this number. We give 100,000 courses, free courses in our platform, and the courses is free for all of the world. So everybody can learn the courses. No need to pay. But who are interested about the platform, you can send me the email to me, and I give you one account to let you try it. But if no account, they cannot access. Okay, thank you.
Okay, thank you. Okay, I would like to open to any live questions from the participants.
Okay.
Okay, share first. Okay, anybody would like to ask? Okay, we have just now a list, Mr. Teguh. We have Mr. Abdul Manaf. Would you like to ask live? Okay, Mr. Ade and Mr. Adi. Okay, then we move on to the next Zoom question, Miss Janice.
Okay, no problem.
Okay, I'll share the screen again. Okay, from Justine Maulina. Good afternoon, Miss Janice. Is that possible to access the course in different language? I mean, some students may be difficult to access it in English.
Oh, yeah. Thank you for your question, Maulina. And actually, I think I forgot to give your audience introduction about the versions of learning management system. And actually, the version of the courses is we have different versions, which is including about the English version, French, and also have Italian and Spanish, and also Chinese. But for the except this for language, if like the Malaysian language courses or content want to upload to the platform, they can give us request. We can give the customized solution for our partners. So they can upload any so different version of courses is possible. So you can try it, and they have the good suggestion or request. Just email us and or call us hotlines to solve the problems. Okay, thank you.
And there's one live question, Miss Janice, from Gurpreet Kaur. Okay, Gurpreet, can you please present your question to Miss Janice, please?
Yeah, I'm from India, Janice. Hi.
Hi.
So Janice, my question was, you have very beautifully shown us the different programs, and you just mentioned that you can customize it for the students as well. So one, I would like to have your email ID so that I can connect with you for that. And my question is, are there any courses for school students also? Because now what I see the scenario is that the school students are more focused over their skill building. So I've suddenly seen that shift during the pandemic last year. So the school students, the grade 11 and 12, which we call it high school here in India, are there any courses for them as well? Thank you.
Thank you so much for your question. I think another one friends also have these questions like vocational courses and content. Yes. First, later I will sharing my email address to the chat box, and also for my company website link to anyone they can learn from our website. And secondly, for the question for higher courses and also for school courses. During my presentation, I was mentioned about one schools from BBS schools in Paris in French, and we have good courses in finance, in mathematics, in English, Chinese, and also French. All of the courses in these schools. That's why our platform have rich courses for higher education part. Also, we are partnership with Ministry of China, and also we are partnership with Minister of DepEd from Philippines, and also chat in Philippines, and where we can customize combine the DepEd, chat, and test courses to combine to our courses together to help the local students who are interested in own courses. We can upload to our platform. For example, Malaysian countries who want to combine our courses to Malaysian curriculum. We can also customize the courses to our platform. That is possible. And also for the vocational schools, we have one demos vocational group in Paris in French, and we have 800,000 courses we can upload to our platform, and to let the interesting learners to learn the French and American countries' vocational skills from the platform. Now we are going to public to everybody, but right now is is ongoing to solve this problem. But who can access to the platform? I can give the one user ID, and they can to learn to try the higher education part of courses and the vocational courses from our platform. Thank you for your question, and later I will sharing my email to the chat box. Thank you.
Thank you for the answer, Janice. Thank you.
Thank you. Thank you.
Okay, thank you, Ms. Gurpreet. Thank you, Ms. Janice. Okay, now Ms. Janice, some concluding remarks from your side.
Thank you. Thank you. I will give. Yeah, really honored to join us today, and hopefully we can hand to to jump the coronavirus pandemic special situation together, and hopefully we can have more time and more conference together in the future. And another one is, I think so many persons is interesting about learning management system. I just remember them, and WIDOM is to support and current the situation of teaching in the South Asia countries due to non-fixed classrooms, and we are willing to provide free courses, free use of learning platform to South Asia countries and elementary to tertiary, including K-12 schools, higher education, and vocational schools for free. And the company also has the platform like the augmented and virtual reality studied to higher education and vocational and technical trainings too. So thank you again for Dr. Mariam and my pretty MC here, and thank you so much for the organizer, and see you next time. And if you have question or more suggestion for WIDOM, please contact me and email me. Thank you so much. Thank you.
Okay, thank you, Ms. Janice. Okay, for the participants, if you have any other questions, please email directly to Ms. Janice. She will give the email address in the chat box. Okay, again, on behalf of the organizer, we would like to express our gratitude to Ms. Janice for the stimulating presentation. Okay, it seems that AI is going to be one of the norms in this new norm era. Okay, when we relate maths education, okay, we hope that the students will be motivated with learning using AI and can apply it in the real world situation. Okay, and hope will increase the interest of students in mathematics. Okay, with this, okay, thank you again, and I'll pass to Miss Lely.
Yes, thank you very much. Very amazing presentations and discussions. Please give a round of applause to Ms. Janice and Dr. Othman. Once again, thank you very much to Ms. Janice for answering a lot of questions, and it is our honor also to have you in this webinar. And Dr. Othman for leading the discussion professionally. Hope to work and collaborate with you all in the future program of SEAKIM. Ladies and gentlemen, before we move to the last keynote address, I would like to say thank you for those who already joined the giveaway on SEAKIM's Instagram by capturing their best moment during today's webinar. We do appreciate it. And for those who haven't joined the giveaway, please do until the end of this webinar. And the committee has shared the attendance link on Zoom chat box and YouTube descriptions. Please ensure you fill in the attendance list as the record of your participations. Ladies and gentlemen, for the last keynote address, I will say, trust me, this talk will be as much as intriguing as the previous sessions. Now we have reached the last keynote speakers for this webinar, which presented by Dr. Andreas Matt from nonprofit organizations Imaginary Germany. His session will be led by the moderator, who is here with me actually in this conference room of Sikkim, which means joining you and us also online today. She is Dr. Farida Nur Hasanah, the Deputy Director for Program of Sikkim. Dr. Farida, good afternoon.
Good afternoon, Miss Lely.
How are you today?
Oh, it's great, really.
Okay, are you ready?
Yes, absolutely.
Okay, but before you lead the sessions, allow me to read your short biography. Dr. Farida Nur Hasanah has been a lecturer and researcher in the Department of Mathematics Education, Faculty of Teacher Training and Education. 11 Maret University, Indonesia. Since June 2020, she was appointed as Deputy Director for Program of Sikkim. She is the founder of KidsScientistCorner.com, a website that provides resources for learning mathematics and science for parents, teachers, and students in Indonesia. Currently, she is researching TPD programs, STEM and STEAM, hybrid teaching and learning, continuing classroom action research, as well as games for teaching mathematics. Dr. Farida Nur Hasanah, I hand over this platform to you.
Okay, thank you so much, Miss. Welcome. Nice introductions. Respect. Are you here?
Sorry, I'm here. I could not hear you. Farida, are you asking me? Yeah.
Yes. Now, can you hear my voice?
I can hear you. Yeah.
Okay. Thank you so much. Before we continue to the presentation of Dr. Andres, let me read the biography of Dr. Andres first. Dr. Andres Matt is the director of Imaginary, a non-profit organization for the communication of current research in mathematics based in Berlin. He has a PhD in mathematics in the field of machine learning and has worked from 2007 until 2016 for the Mathematics Forschungs Institute Oberhof, a Leibniz Institute, where he co-initiated Imaginary. What is Imaginary? Imaginary is currently involved in a major training and teaching program in artificial worldwide and has developed a digital and physical open source AI exhibitions. Professor Ramanujan also mentioned that Dr. Andres Matt is one of the heroes in this field in his presentation in the first sessions. And in 2013, he received the Media Award of the German Society of Mathematics for his achievement in communicating mathematics. So without further ado, please welcome Dr. Andres Matt. Time is yours.
Thank you, Dr. Farida. I'm very happy to be here. Good morning. It's very early here on this side of the planet, and I'm happy to see so many people. I also maybe have to start with an excuse that I could not listen to the previous two keynote talks, which I will catch up later. I've briefly glimpsed into it. It's super interesting. So please forgive me if I repeat something that has already been mentioned. I'm going to share my screen. And yeah, can you see my screen?
Yes, absolutely.
Okay, perfect. So as a short visual introduction of myself, I found this picture from the year 2002, quite some time ago. I was still doing my PhD work in mathematics, which was kind of new at that time to work in AI. So this was in reinforcement learning, machine learning, stochastic processes. And so here, this was in my office. At that time, I was playing with some robot dogs, which were not really AI, more like toys. And on the right side, it was interesting because at that time, I did my first mathematics exhibition. This was while I was still studying. And this was completely new for me, doing exhibitions, like entering the field of non-formal learning in a way. it's interesting that after some adventures in research, I'm now doing this professionally, full-time. I'm doing mathematics non-formal education, especially in the field of exhibitions and museums. A few words about Imaginary. I also put the link here. So the website is imaginary.org. It's a non-profit that started at a research institute for the German Year of Mathematics in 2008. And the idea was to do an interactive traveling exhibition. And it was very successful. So we started doing it outside Germany. And after, I don't know, 8 or 9 years, it became an independent non-profit organization. So we are based in Berlin, but we work on a global level. And the main philosophy of Imaginary is to do everything under open source licenses. So everything we do, all our exhibits content is freely available under open licenses. And the idea is to be as close as possible to current research on the one hand side, but on the other side to be as attractive, interactive, explorative as possible. So I think that's the core of Imaginary. Here you can see some images. We invented this format of open source exhibitions. So many of our projects are not done by us. They are done in collaboration with local partners who copy our exhibits and just stage their own exhibitions, change the content. So it's a very dynamic way of collaborating, of communicating. In terms of AI, I'm going to give you a little glimpse into what happened in the last years in the non-formal field, which is interesting because there have been some AI exhibitions. So far, I haven't seen an AI museum yet, but I'm sure that it's coming. And currently, there are a lot of AI exhibitions in the planning, new ones. The former AI exhibitions so far that I have seen are more related to applications, maybe also the art and AI side. The new exhibitions, which are now in the pipeline, so there are several, one in Paris, in Finland, in Sweden, also in Germany, planned to be opened maybe later this year or next year. They are also now more focusing on the core mathematics, or like the core algorithms of AI, which I think is very necessary. We started 2 years ago. Again, interesting, 2019 was the German Year of AI, of artificial intelligence. In Germany, we have the science year. So for 1 or 2 years, the whole country is focusing on one topic. And then they do a lot of events and whatever exhibitions, talks, and it's very, very present in the media. So 2019 was the year of AI. And we joined the year with a workshop series. And a lot of exhibitions at like public spots in train stations, and there was an exhibition on a boat traveling through Germany. And from that on, we developed a whole new exhibition, which is called I Am AI, explaining artificial intelligence. And the idea of this exhibition was to really go more into the details of the core methods, like to really explain, I don't know, how does a neural network really works? How does it work? How can you train it? What is gradient descent? What is reinforcement learning? I'm going to show you some of the examples, but the idea was really to show the mathematics of it. So this exhibition was conceived with the support of the Carl Zeiss Foundation, and it's an exhibition that we could not, like a physical traveling exhibition that we could not start yet because of COVID-19. So it's still waiting in the storage room. Hopefully we can start in fall this year. And it's also, again, an open source exhibition. It comprises of 14 exhibits. And here you can see a little bit into the exhibits. I'm going to show you some of them in a couple of minutes. And many of the exhibits use touch screens, but they also use video cameras, microphones, different input devices, and they invite you to explore AI in a more self-discovery way. Here you can see some images, like ray-traced images of the exhibition. Since we could not start the exhibition in a physical way, we decided to do it in a digital way, which was in a way new for us. We are very digital as an organization, so we do a lot of software development, and we feel at home in the digital world. But But so far we were always working with real physical interaction. So this was kind of new. So we started a digital exhibition under the domain im.ai, and we were looking at formats. We call them, or they're called explorables, or explorable explanations. So on our website we call them trails. So these are kind of interactive stories. On the right side you see an example that include videos or maybe interactive applications, pictures and stories, and you can just read and play along. We were also testing something that we call interactive video. So you can see here on the left side an example. So there's a pre-recorded tutor that explains you something while you interact with the website. So you do something, and then the pre-recorded video talks to you, and then the person in the video changes your screen, and so the time code of the video is connected to what you do. So that's also a format that we developed. We started this project in June last year, and it was a very, very big success. So interesting for us that suddenly we were doing everything online and everything in a digital way. So of course you have the classical whatever online talks. There were online exhibitions. Here you can see an example at the World Intellectual Property Organization. So there was like a 360-degree video exhibition. They used some of our formats, and reported like most of the exhibits, whatever is possible, into the web. So of course, if you look at AI, some of the exhibits are very difficult to run in the web browser because you need very strong computers, very good graphic cards. So that's not impossible. That's not easily possible. But we managed to port many of them on in the web format, and started developing a kind of a workshop format around. And I'm very happy that we could start a long collaboration with the Goethe Institutes. That's like the German language institutes worldwide. And we conducted so far more than 50 or 60 4-day-long training programs on AI for school students. So that's interesting. It's school students age 11, 12, up to 17, 18, mainly 14 and upwards. And these 4-day-long online courses were part a German language course, which is interesting. But then, of course, going into the mathematical details of some of the core AI algorithms. So we learned a lot how to do these online courses. We developed our material, and we also added a whole series of teacher trainings. So I think we did about 16 or 17 teacher trainings for STEM teachers. And so that's also interesting that we not only used the material ourselves, but we also like went one step above and tried to prepare all the material in a way that others can also reuse it. Before I go into the details of the reusability of our content, let us just jump a little bit into the content, and I'm going to show you how we do these workshops. I will show you some of our interactive apps, and I will also introduce some AI right now. So for the ones who are AI experts, look at it from the didactical level, and for all the others, enjoy AI. I used to show in my workshops or in my talks this Super Mario World Card. I don't know if you play video games or you played video games. I often like to look at science in a way of a world map. I like this, that you have these continents, you have the kind of islands, you have the cities, and you have the connections in between. And this is not a fully professional scientific map of what's happening in AI. I'm just seeing that there's still some German word here, genetic algorithms on the top. But I like this, that in the center at the moment, you have this big island, which is the machine learning island, with the 3 pillars, the reinforcement learning, the unsupervised learning, the supervised learning, using similar tools like neural networks. And then around that, you have, like in the north here, you have this frozen island country with maybe some older AI systems, like what you previously called AI. Now, maybe you would not call it AI anymore because it's different mathematics algorithms like expert systems. And then on the other side, you have these application islands where you do natural language processing or computer vision. I also like this kind of new islands coming up, the volcanoes creating new islands where the mathematics is just being invented, like causal inference, for example, causality, which is a new field. And then you have a lot of connections. You have the tools that you use, and you travel between the countries, and you explore it in a way. We're going to start now to go, of course, into machine learning in the central island, and we'll start with neural networks. We developed an exhibit which is called Neural Numbers. And now I also invite you to play along. So there's a link list that I'm going to share with you in the chat. Let's see. And then, yeah, I invite you to play along. So that's a list with different interactive programs. We use these link lists a lot in our workshops, so it's easier just to say, okay, now let's start with exhibit number 2 or exhibit number 3. So you can open here the exhibit number 2. Can you see it? So now this is all about, like, I would say, what's the difference between a normal computer program and an AI or like a data-based computer program. So the whole idea here is to have a software piece that recognizes handwritten numbers. So I can, here in the input field, I can just draw a number, and then I have this confidence bars on the side, and the computer would tell me, okay, I'm very confident now. This is a 1. I can draw an 8. Okay, I'm very confident this is an 8. And while you draw, you can see how the confidence bars go up and down. So the computer program tells you what it is. If you try to program such a software, you can try. Yeah, you can try. That's a good exercise. For example, to find the rules. How does a 3 look like? That's the normal computer programming way. If this looks like this, then it's like this. If this happens, then this. So if you try to specify the shape of numbers, you will run into issues very quickly, because there are so many ways, and maybe there's just a little bit piece missing, but it's still an 8, or I don't recognize it. Now this is even wrong here. So one way is to specify each detail, like I have a straight number here, a straight line here, a straight line there, or you use a training set. So I invite you here to play, and maybe you can find a number that the computer does not recognize well. So that's also interesting. In our workshops and in teaching, this kind of breaking the system is always very attractive. I give you this mission. Can you find a number that you recognize as a number, but the software does not recognize? So we have software pieces that are trained by data, and if you click here on the third tab, now I have this one is a neural network to recognize numbers, which is trained only with 300 images. So trained just a little bit, and you can see it's not very confident. It also doesn't work that well. You can also click on the fourth part, which is the same network but trained with 1,500 images. So here you can see it's already much better. So it would recognize, I don't know, like a 3. Most of the numbers it would recognize. You can, of course, try different things, like, I don't know, what happens if I do a dotted line? I don't know, I try to make a dotted 0. Yeah, it would recognize it. You can tilt the numbers. You can, I don't know, really play with it and see how it works. So there's one thing now going a little bit deeper. So the first level was this kind of, you play with a software piece that has been trained. So the different states, trained a little bit, trained better, trained very well. And then we have this kind of, what do we do with our input? So I draw a number here. And before I send this number into the neural networks, I apply a certain transformation. In this case, the normalizer, what it does, it's that it downsizes the pixels of the image. So we'll make it a 28 by 28 pixel image. And it also scales the image, so it's always more or less the same size, and it's placed in the center. So here, for example, if you draw a small 3, you see it would become big, centered, and in the same size. So this is what I do with all the input. I'm going to show you now a different version, which is like more the exhibition version of the same exhibit, the same interactive. So here again we have the recognizer. Now it becomes interesting. Now I can also train my network. So I start with a network which is randomly initialized. So here you can see it does anything. And then I can use sample sets. I can show you the sample set here. The so-called MNIST data set, which is an open data set of hand-drawn numbers. So they're hand-drawn and they're labeled. So that's very important. So you have the image, and then you know that this image is a 5. So you have 80,000 images of numbers or digits, and they are all labeled. So I have, I don't know, 10,000 zeros, and I know that it's a 0. So that's very important that I have this data set. Here you can see some examples of the 1s and the 2s and the 3s. Also to show you, here you can see the input of the image. Just make it bigger. So it's really 28 by 28 pixel dots. And what I show the computer is the colors of these dots. So I have a vector of 28 by 28 numbers, and the numbers here are between 0 and 1. 1 would be a white color, and 0 would be black. Since we have some gray colors here on the borders, it would be, I don't know, 0.2, 0.8, 1, the rest would be 0. Good. Coming back to the network. So now I have the training data, and I have the network that I'll show you later. How does it work in detail? But the connection would be, now it's not trained, so I can use it. I don't know, it's not very good. And now I can feed in training images. So I can just click here on start, and I use, I don't know, a couple of hundred, a couple of thousand images. I can, whenever I want, I can just stop and say, okay, now I trained this network with 1,600 images, and I can test it. It's already quite good. It's interesting that here on the right side, it says predicted accuracy. That's something that you often do when you train a network, that you take part of the training data, let's say 80% of the training data you use for training, and the remaining 20% you don't use for training, but you use it for testing. So I used 1,600 images from the training data part, and then I test it if it works fine, and it's fine for 86% on the training data. So in this sense, you can also kind of look how well the network improves. If it gets better here, now I'm 90%. But this only shows you how well it performs on the training data. It doesn't show you if how well it performs if I put a new number here, which is not part of the training data. So that's maybe one of the first magic things of neural networks, that they generalize. So they don't only work on the training data itself, but later they also work on other numbers, that because this tree, as it is here with these pixels, is not part of the training data, but it still works perfectly. So there's this layer of, I have training data. I use the training data to change the network in a way. If you look here at the lines, at this artificial neuron connections, they're changing in color. So this means that something is changing here. Some numbers are changing. So I think the blue lines are for negative weights. The reds are for positive ones. We're going to jump into the detail what this means mathematically, but here it's really just more introducing that you have something that becomes better. I have training data, and then you can ask a lot of questions. You know, what, for example, I don't know, what happens if I want to teach the network Roman numbers, or if I want to teach the network, I don't know, letters. So of course it does not recognize a letter. It would say, okay, this looks like a 9, but you can also ask your students, okay, but then I have to change the training data. Or how important is training data in general? If I look at the training data here, I see that the ones are the American ones. So it's the straight lines. In Germany, we use a one which rather looks like this, which, for example, here, it's not sure. Is it a 1? Is it a 9? Or is it a 7? You know, if it's because we usually put the 7 here. So it still works with this 7. So it's very dependent on training data. And that's also super important just to feel how important is training data. You know, the accuracy of training data, the training data is labeled, and this whole question of where do you get the training data from? There's an advanced level here where you can start changing the architecture of the neural network. You can change activation functions, optimizer. I'm going to show you about this later. But it's also interesting that you can try to play with different settings. And here again, you know, I don't know, how can I get a higher accuracy with a low number of images, for example? and just use 2000 images to get very high? Can I change the learning rate here? And can I play with it? Okay, so that's the first exhibit. And now the question is, how does it look inside here? Inside this artificial neural network. How is it trained? What happens if I show the image a number? If I train it here, so I show the image a number, number 5. This is a 5. So I show the image. Okay, this is an 8. It would say 3, but it's not a 3. It's an 8. So there's a gap. There's an error between what the network tells you and what it should tell you. So how can we train these networks? And for that, if you jump back to the linked list, we can open number 3. This is called gradient descent. So this is a game. I can also share the link directly. Here. So you can also play along. That's a lot of fun to play along. I usually in online talks take my pirate hat, which always works very well if you do it a little bit less formal. So the story is there was this pirate like 300 years ago, and she hid a very, very valuable mathematical treasure on the bottom of a sea, on the bottom of the sea level. And now a couple of hundred years later, we have this exploration boat, and you can go left and right. What happened here? So you can go left and right, and if you either click on the blue button, or you can use your arrows left and right. If you click down, you can lower a probe to the ground of the sea, and that's the thing you can do. You have 10 probes, and whenever you lower a probe, you get a feedback on how the sea level on that spot would look like. Now I ask you to play and find the treasure. The treasure is hidden on the bottom of the sea. So you have to find the deepest spot just with 10 probes. If you find a treasure, you can put it in the chat, the treasure that you found. It will give you a name. So there's mathematical treasures put in here. I'll leave you for a couple of seconds. Let's see if you find some treasures. The sea level, whenever you play the game, is generated randomly. There's a certain way how we generate them. Yes, the first treasure was found here. Nita de Lima, you can also put the treasure that you found. We put some nice mathematical treasures in here. And just put them in the chat. So I will also try to find one. I have 2 probes left. I don't know if it's here. No. Okay, my last probe. No, I didn't find it. Game over, I can play again. So I hope that you find some treasures. Just put them in the chat, whatever you find. The idea is, of course, to find the treasure, but if you play very often, that it's more about how can you find the treasure. So where do you start at the beginning? What do you do? If I have a slope like this, okay, I would probably go on that side. Okay, maybe the treasure is here. No, it's not here. So that is probably just a local minimum. I have to find another more global minimum. So I have to look. Difficult. Some curves are very tricky. Maybe difficult to find the treasure. Okay, now I found the treasure. So for example, I found here the instructions for squaring the circle. A very valuable mathematical treasure. And once you found the treasure, or you run out of probes, the curve below is shown, and you can see the issues of certain curves. And that's also something that works very well with students. This whole discussion of what's a good way to find a treasure? Where do you start? Should I start in the center, randomly somewhere? And then what do I do? So I get a slope here. Okay, I go down. Maybe then I jump to another place. I explore some other area. I usually try to follow the gradient. So that's why it's called gradient descent, in order to find minima. Whatever, is it a local minima or global minima? Wow, somebody found Fermat's loss proof. That's of course also a very valuable treasure. You can imagine that also works very well. Like if I ask you, what would be difficult sea floors, for example, if you have a very flat sea floor and it doesn't give you any clue about where the treasure is hidden, that's, for example, something very, very difficult to find the treasure. Like imagine you have a sea floor which is like this, and then the treasure is hidden here. Very difficult to find. Or imagine you have a sea floor which is like this. super bumpy with a lot of local minima. How do you want to find the treasure here? So let me see if I get back to the, yeah. Okay. Sorry. Okay. Just like this. Good. Any further treasures? The last digit of pi. That's also very good. All right. I just stop my sharing for a second. Get back. All right. Now, what's the connection of the treasure, or the way how to find the treasure, and the neural networks? So first, what's interesting is to discuss the method. So this is a good example. I like this very much in our work, that we provide some tools. In this case, it's really like a game, but in a way, when you play the game, you find out the algorithm. I don't have to explain you what is gradient descent. You just find out yourself, and you find out yourself. You self-discover somehow what are difficult grounds. Maybe how much should I move? You know, if the slope is very deep, should I do a big step? Should I do a small step? Should I do a big random step somewhere else? How can I go down? And that's very interesting. That it works very well with students, even younger students. That you immediately, there's a big intuition how to find the good algorithm, and you can discover gradient descent in a way on your own. Now, how does this connect to neural networks? The curve you see here is the error curve. So it's the curve, I mentioned this before, the error between what the network should do and what the network does. I'll show you the error in detail a bit later, but there's a gap. So at the beginning, if you look at the network, here at the beginning, I don't know, it should tell me 3, it gives me something. So there's it should tell me 4, it gives me something. So there's an error between what it should do and what it does. And this error, you can imagine this is it's a curve. If the error is 0, the network is perfect. So what you try to find is to improve your network. So the position of the boat would be the network. So I start somewhere randomly. Now I'm far from the bottom, so it's not very good. Now I try to improve the network. I go further down. Okay, now I'm better. It's a better network. I go further down. I try to improve. Okay, now let me see. I found the global minimum. My network is good. It's trained. So this is it's training on just with one parameter, left and right. So I just have one number that I change. In the neural network here, it's not one number that I change. There's a lot of numbers. So each line here would be, for example, a number. And I change all these numbers and I improve my network to find the treasure, which means to get a network which behaves better and does what I want it to do. Like it fulfills the training thing. Now we can even go a little bit more deeper and even more in mathematics. I'll show you. I'll take off my parrot hat. So now I think it's very important to get a glimpse into what is an input, what is an output. We have seen the example of an input in terms of numbers, for example, like the numbers of the color code. The image would be an input. And the output would be the confidence bars. Okay, this is a 3, for example. In terms of mathematics, if you look at one of these small circles here, this is an artificial neural network, and they have all the same structure. So the structure would be that you have numbers coming in, the x1 to xd. Then these numbers, values are multiplied by the so-called weights. So you have x1 times I1, and this you do with each input. So let's say all the color codes are coming in, and then you weight them in a way. You say, okay, this 0 is not important, the black is not important. This white spot, for example, I don't know, in the number 8, there's something in the center. So because it's where the two circles meet, so it's important that there is some white in the center. So this input here on number, I don't know, 400 is very important. So I give this a very important weight. And the weights I can change. The weight is the position of the boat. And I sum up, I have the summation of all these weighted inputs. I add another number. This is the bias, which gives a certain strength to this whole neuron, not just to the individual weights, strength or weakening it. And you have mathematically very interesting nonlinear or semi-linear nonlinear activation function phi before you get an output. Now this you can do with each neuron here, and what's interesting is the whole connection of it. In terms of the activation function, very often nowadays you use the so-called rectified linear unit. So here on the top right, it's simple to show. So only positive numbers are channeled through. Everything else is zero. So it's whenever there's a negative input, it stays zero, and as it becomes, it stays the same. Now, this you can introduce in mathematics in a very formal way. In terms of mathematics, I think it's doable because it's multiplication sum. There's one function here, but the complexity is more like in the connections that you have a lot of them. So there's the whole series. You do this a lot of times, and in very large networks, you do this millions or billions of times. But you can also use tools for it, and I'm going to show you now a tool that we use to introduce these mathematical details, which is called we call it Simple Networks. It's still a prototype, so we're still working on it. If you go in the chat, like in the link list, I will also put it in the chat. The design is not yet ready, but we already like the way it works. So this is now an interactive explorer of neural networks. I start here with an example. I start in the center. So let's say I want a network to convert Celsius to Fahrenheit. So I have an input, which is just a Celsius value. I start here with 0. So I can put an input. The blue dot is the weight. So I have, I don't know, 9 times here 0.77. And then here I have a bias, which is just a number that I add or subtract, just a number. And then I get an output. So it's a very, very, very simple network, just one connection, one input, one output, one neuron here. And the activation function is the ReLU function. You can see it if I put a negative input, you see it's always 0. And only if I get positive, it becomes positive, here the blue line. Now comes the interesting part. So I have this architecture, simple network, and I have my training data. Again, training data. So I know 0 degrees Celsius should become 32 Fahrenheit. So if I put this on 0, I get 40, which is not 32, but okay, it's close. Then 10 degrees should become 50. Now I'm here on 65. So I'm also wrong. There's also a gap in here. Now, if you look at the error, you see 14.09. There is an error. So the current network, if you look at it from the training data point of view, it has an error of 14.09. So it's not very good. So now let's do gradient descent. Let's improve it. I'll take the weight. I'll put it a bit down. Let's see. I'll improve it. This is like the boat. I changed the position of the boat. I changed the network. Let me go here. You see the error is becoming smaller. Wow, cool. So now it's already good. For example, for 20 degrees, it tells me 63. It should tell 67. So it's kind of good. It's better. So I can still improve it a bit more. Oh, my error goes down. Great. I try to put it a bit more. My error goes up again. So that was not very good. So I can hand tune my network. I can hand train it. I can change the bias. I can change the weight. Now, if you click here, you can also just do automatic gradient descent. Like that you go with the gradient, and I train it by hand, like by hand manually with the gradient descent method here. And now I have a network that has 0 error. You see? So 0 becomes 32. It does exactly what the training data should be. Of course, you can imagine this is a simple function. So it's like I have a whole neural network just to learn a simple function. But it's a good example of the universality of this architecture, that you can actually approximate functions, and functions that you don't know. I just have the training data. I don't know the function to compute Fahrenheit. Even if it's a simple function, I don't know it. I don't have to know. I just have to. I need some training data, and I need gradient descent. And this now you can do with all types of questions. So you can, I don't know, try to train a network. That's also, you can imagine, not so complicated, the average of inputs, but you can also whatever the maximum of inputs. You can do a lot of examples. You can also be a bit more complex. So here you have, I don't know, something like, am I inside or outside? What is the amount of clouds? And then I can predict the temperature outside. I have a training data, and I can just, again, use gradient descent and see how the network becomes better. Here you can see that it takes some time. Yeah, maybe it would get stuck in a local minimum, but now here again, it's trained. Now I have a perfect network. And you can also do this for XOR functions. This is interesting that here sometimes you would get maybe stuck in a local minimum. So you have to do some exploration step in a point, change the weights a bit, and then you can see how good I get. So the combination of having a tool and the mathematical explanation, and I think it helps a lot to understand the dynamics of it, even if it's just simple multiplication and some activation functions. We have a lot more of these tools, not only for neural networks, but also for reinforcement learning and for other topics which usually are not dealt with in mathematics, but there's something on ethics, NAI, for example, or like more philosophical questions. What does it mean to understand something or to know something, which I think is also very interesting going into the Turing test or Turing game direction. Now, I have 6 minutes left. Yeah, I want to introduce you to our current project, which is the logical consequence of the work of the last year. That since we have gained so much experience now using all these tools, developing the tools, adapting them, and also using them in teacher trainings or in school workshops. So the idea is now to put this all together, which I'll show you in a minute, and to have like an open IMAI curriculum. So the curriculum would have all the interactive apps, of course, with the source code and the different versions. We also have some analog games and hands-on construction. So it's not that you always need a computer. You can do a lot of things also in hands-on ways. So like build your own paper cup AI that trains, for example, playing a game, but it's only made with paper cups and pencil, no computer needed. We also have whatever discussion games. We have some insights into the history of AI, like a small game where you play the history of AI and the detailed explanation sequences. So how would you introduce a topic? What are the questions you would ask? What are the things you can discuss, or you can go deeper? Of course, going deeper in terms of the mathematical background. Also with a lot of further references. That's also one thing that we felt a lot during these workshops, that there's a big interest with the students, all ages, to know more. You know, can you give me a video? I want to know more. I want to explore more. So it's now there are a lot of like very good YouTube channels, even for more general public or for younger audiences on AI, or some online kind of courses that you can give them as a reference. And I think that's also very, very valuable to have these references, of course, for the teachers, but also for the students. And we just started to have also something like worksheets that you can hand out. So it's more going into the formal context of teaching. We live in the non-formal world, so we're not doing tests. We are just exploring altogether. Now I can show you the first draft of this curriculum. Just see. Yeah, I'll show it to you here. I don't know if you can see my screen. Currently we are doing it in 3 languages: English, German, and Spanish. The English one is the most advanced. And the idea is that we here have a list of all the modules, and we are also adding whatever schedules for classes. We have videos and all the tools that we use in online workshops, mainly at the moment. I'm going to show you some examples. So for example, here you have the gradient descent game. You have the different versions of the app. There's also a version, for example, where you can play against the computer. I don't know, I can show you here. I play, for example, against here a computer who is doing gradient descent. So you can see how a computer would perform here, for example, getting stuck on a flat ground. So this is a version where it just does gradient descent. There's no jumping. And you have this whole story of the explanation sequence. You could start here with the pirate story, like how to play the game, what can the participants discover, and then you can go to the connection to error functions. We even here have a version of the game, I can quickly show you, which is higher dimensional. So I think it's also interesting that you do this gradient descent not only in 2 dimensions, but you do in 1 dimension, but you can also do it in higher dimensions. It would still work. So here we plan the same game, but you do gradient descent now in 2 directions. So tuning 2 parameters at the same time, but the concept is the same. So in this sense, I don't have the curve, I have a surface, but I can still go to the deepest point, and I can still just look at the gradient in more dimensions and still go down, and it would work at the same time. Nowadays, you have these dimensions where you, like the neural networks, where you have billions of dimensions, but you still do gradient descent or version of gradient descent. So there's a lot of material that we are collecting. There's also worksheets here. Some of them, we still have them in German that you can print and hand out and use. Here, for example, a worksheet where you work with this gradient descent game, and then you try to think about the strategies and the curves and plan your own seafloor, for example, and how you discover it. The curriculum is going to be open source and is going to be published once it's ready, but I invite you for free early access. So that's something that I decided yesterday, since we have so many teachers probably among you. I think it's good. The early access would mean that you can access all the material, but we would do it in a more controlled way a little bit. So I have the email addresses. We are not publishing it right away, and I hope that you can send us some feedback, on the material if you test it or if you look at it. I will share the link. So if you're interested for the early access, just fill out this quick form, and then we can provide you with the current version, or you just wait. I guess it will be 1 or 2 months, and then we're going to publish it anyway under completely openly the whole curriculum with all the materials, so not just the things that we have seen today. So to conclude, I think there's a big potential in the material that we developed. First, just for an exhibition, now for workshops, and I think it's going more and more into direction school. We do this like the teacher trainings, and I think the tools that we have and the explanations around are very, very valuable for the school context. And there's of course a lot that you can still add and do, but we are now going to this direction, and I'm inviting you to join this movement of this material, to add all the resources that you have, to develop whatever the handbooks around, to test the material, give us feedback, and we can do translations in all languages, and also add new ideas. We have seen the world map of the AI field, so we can also add new ideas and new tools and build a community, and in this way, like enter the AI in mathematics education field, maybe from the non-formal side, which I think is for students also like a different approach, or very attractive, and you can still do the mathematics then in your normal course, or the students do them on their own once they're interested, and once the curiosity spark is big enough, they will just discover on their own. Thank you. Feel free to contact me. I put the email address here. I will also share the slides, so you have the slides with you, with all the links in there, also the link for the link list slides. And I'm open for questions.
Okay, thank you, Dr. Andreas. How should I call you? Andreas or Matt? Which one do you prefer?
Andreas is my first name. Yeah, Matt is the last name, so Andreas. Yeah.
Okay. It is lucky for us that today we can learn much from Dr. Andreas about artificial intelligence, because most of our participants here are mathematics teachers and educators, and also researchers in mathematics education field. So now let us see the question that they already received from the question and answer session. I will share this screen for you so you can also read the question. We already have 3 questions from the Zoom platform. Okay, first I pick these questions from Nuri Martini. So it seems like she would like to ask about what kind of skills could be developed in the mathematics classroom so that it can be able to adapt with the technology, especially in artificial intelligence. So is there any specific skill that teachers need to teach to their students so they can build computational thinking skill? Because probably the teachers thought that artificial intelligence is closely related with the computational thinking skill. So could you please explain?
Yeah, I mean, I think it relates a bit to this, what I mentioned when I showed this neural numbers experiment, introducing that it's not the classical way of programming by rules, but programming via data. And I think this data-driven technology, that's something which is a little bit of a shift in how you approach computational thinking, but still you would need all the classical programming skills, and that I think it's just building on top and saying, okay, now I'm not doing if then, like if you see two circles, then it's an 8, but I have a training data, and then I have a technology, like, I don't know, it's a mathematical tool set, like this neural networks architecture, and I have the architecture, I have the optimization method, I have the gradient descent, whatever, and then I can just put in data and get out a software piece that does something that I wanted to do. And I think that's a little bit of a shift in a way. So I would say like this data-driven thinking is very important, like everything around data. And then of course, I would say everything related to probabilistic theory. There's a lot of statistics in AI. And I think that's also depending on the country where I think in my mathematics school, I just had a little bit of probability. And I think that's also, you could even say that's a different branch of mathematics. So it's also a very different thinking. And I think these two skills are very, very important, apart from the normal programming computational skills.
Okay, thank you so much, Dr. Andreas. Yeah, actually here, at least in Indonesia, the probability also still lack of space in school curriculum, I think.
Yeah.
So very interesting. And then the second is, I think this is quite important and very interesting questions. So, Dr. Andreas, what your opinion is the AI can work in developing country faster, and how it can affect the education of developing country?
It's very interesting because I was thinking a lot about this issue now, also a bit in this race for AI between the US and China, and Europe is trying to catch up as best as it can in terms of applications, research, and data. Here again, the word data is very important. So we were giving together with the African Institutes of Mathematical Sciences last year, we gave a very big conference for AI on the African continent with a lot of input from local researchers. And the question of how can you build up an AI infrastructure on the African continent was very much related about, again, data and the supercomputers. There was one interesting thing is, that you do not necessarily need all the supercomputers, since there's a lot of now frameworks that also run on mobile phones, and you could use different types of computing power, which is also important, the computing power. But I think one big issue is also is the data, where in some contexts or regions, you just don't have the data. For certain languages, for example, you cannot train a natural language model if you don't have the data. I have the feeling, and that's maybe my mathematician's heart, that you can always just catch up with algorithms and theories and inventions. And the inventions are not related directly to the resources. Indirectly, yes, because it's the education that you have. But I think clever ideas are independent of data and computers, and we have to work in an international level anyway in science. So at one point you would connect to the international world, and you can use the supercomputer from South Africa in other countries or whatever. But I think you can catch up. I think the question of adding AI to school is a question that I haven't seen answered in any country yet. I don't know, but maybe I'm not doing enough research on that. But I it's somehow there are projects, but I don't see it integrated totally. And but I see a lot of interest with the young people, and they would just do it on their own. If it's not given in school, maybe they just start programming on their own.
Yeah, just like Tenmai from India, the one who worked for the IBM, the Watsons. So I think that he also learned by himself about the artificial intelligence. Yeah, because it is still difficult to find out the research from the former curriculum in any nations. I agree with you with this one. Now, let's move to another question from the Slido. I will share here from the Slido. We have 3 questions. I think, but it's still related, 3 of them. The first is, do you have any training program for educators about AI? I think it's already answered that we already give training for 16 teachers. Yeah, we do training program for teachers, educators, but we also do training programs now for scientists. So that's also interesting. So we're adapting our tools also for higher levels. So we also do trainings for students, whatever postdoc students who are not trained in AI, like mathematicians, for example, on certain topics. And then, but we have already like a training program which uses mainly our tools and adds certain levels of whatever didactic competences and more mathematical background. So we have that. We are also going to open that curriculum, which is intertwined somehow in this curriculum for schools. It's also the curriculum for the training program because it's related. So happy to do that. We are an independent organization without any funding. So just to mention that, so it's a non-profit, but we cannot offer the courses for free. We can offer the resources for free. So, but not like our human time. We have to see to do this together with some partners. But the training program is there, and happy to further develop it, or happy that somebody else takes over the trainings, and we just do a training of the trainees, and then you can do your own local trainings, for example. Yeah. Oh, that's very interesting. Hello, Dr. Andres. We still have hello.
Yes. Yeah.
Okay. Still have one more question here. From Rosalie, teachers are user of AI. We don't have the expertise in EAs. Yeah, he said like that. I don't know. Is there any templates for us to implement it?
Yeah, I mean, it's a big question. What do you mean with implementing AI? So, do you want to program your own neural networks? Do you want to play with it? There are tools. There are, of course, frameworks you can use. There are some like some of the tools that we have. There are more tools. There's Google has. They have some AI experiments where you have a teachable machine. Maybe you have seen that earlier. So that's also nice. It's like a neural network that you can train on the spot with images. I think like the resources we have are somehow to get you introduced as a teacher. For me, what I'm very curious, and maybe that's also something in terms of feedback, the question to you, the audience, what's your favorite template? How does the best template look like? Often, like, is it AI or any other subject? How would you love to be introduced to AI? You know, is it like text? Is it images? Is it videos? Is it a combination? Is it worksheets? So what do the teachers need? So maybe that's a question that you could give as a feedback. You know, what's the perfect template for the template, you know? And then we can put all our content into that template, and you are happy. So I'm not sure. Like now we are following this approach with this kind of like explanation sequences and videos of workshops and whatever. But I don't know how. Maybe you want to see more mathematics. Maybe you want to do more programming. Maybe it's also diverse, the answer. But that's maybe a good question for you also to.
Okay, thank you. Probably, Dr. Andres, I also browsed the website of Talk About AI. I am AI. So you provide a comic for introducing AI. Yeah, I think probably we can suggest teachers at least to read first, so they can learn about AI, and then based on the knowledge that they have about AI, then they could create or design by themselves what kind of template that actually they can introduce in their classroom. We already have 3 attendees who already raised hand. Would you like to give him opportunity to pose the question directly to you, Dr. Andres?
Yeah, for sure. I just realized that I put all my links into the wrong, I just sent it to the
I will
panelists.
help you to, I already opened it, so I will help you to post the link on the chat rooms.
Yeah,
okay,
perfect.
so they can grasp all the, we need to talk about EA.
Okay, perfect. Yeah.
Okay. Now, I will unmute one of the attendees here. Here's from Mr. Munawaro or Miss Munawaro. Hello, can you hear me, Miss Munawaro? Hello, Miss Munawaro. You can unmute first your microphone. Okay, no. Now we go to next, Mr. Alim Wijaya. Mr. Alim? Hello?
Yes.
Yeah. Yeah, please pose your question directly to Dr. Andreas.
I want to know how to make the program like both. It's how to make AI, artificial intelligence, for our student to make study more joyful and etc.
Oh, okay, let me help you. So, Dr. Andreas, probably Mr. Alim asking is about how to use AI to create an applications that can help teacher teach mathematics in a joyful way. Is that your question, Mr. Alim?
Yes. Yes.
Yeah. I mean, I don't know. I think the way that we do there's things that I showed you. For me, it's joyful. I don't know if for the students or for the others, but to have this more interactive self-discovery approach where you play some games, you have direct feedback. We have a small robot simulator for other things. So I think that's a joyful approach where you can directly explore and see things, and it's not. So maybe if you look at the IMAI website and the materials, I would also like to post this early access link again for everybody. So if you want to get access to our curriculum, I put this again. Go to this link, and then you can go into it. I think that's probably a joyful approach. I don't know what more joyful. I don't know. We can do an AI dance or something. We can see, or an AI song. To add something even more joyful.
I think you show very interesting thing.
Okay, thank you, Mr. Ali.
You're welcome.
Okay.
Very good.
Okay, thank you, Dr. Indriani. Very interesting. Actually, Dr.
I like
Andreas,
it very much.
Yeah.
Playful, joyful. The kids will enjoy the learning process. Okay.
Dr. Andreas,
Thank you so much.
Dr. Indriani is one of our moderators for the first keynote speakers today. Okay.
Yeah.
And actually, we still have another questions in the question and answer sessions, but seems that I asked the MC, do we still have any time?
Yes, please.
Okay, we still have 5 minutes more. Here there is a question from Justin Maulina. Good afternoon, Mr. Andreas. Can we exploring AI in calculus in the topic of differential or integral? As teacher, this topic is difficult for some students, not only some, probably many students. Maybe AI can make it more interesting. Thank you. So please.
Yeah. I mean, I don't know if you covered the topic of using AI not as a topic in education, but as a tool to improve education. I don't know, AI tools to improve mathematics education. That's a different topic. So it's not about AI itself. It's about using AI methods. I'm not an expert on that. I don't know how you can use AI to teach calculus. But maybe again, if you have some, I don't know, like a real example, you have the gradient descent and you have to compute the derivative of the curve in order to see the slope. So that's also something that it's more like, maybe in this sense, you have a direct, okay, now I have to do a differentiation here, but it helps me to find the treasure. Maybe it's a bit more appealing in a way, but I think the question is not using AI or not. It's like go into mathematics didactics and try to find a good way to teach calculus. And it's not, I think it's not related to AI in a way, But of course, you have AI as an application field, and if you have a good application field, that might motivate, for example. But I don't have any other approach rather than just good mathematics teaching, that with or without AI. That's it.
Yes, yeah, it is understandable. You are mathematicians. We know that you are mathematicians. And Dr. Andreas, and could you, before closing this third sessions, could you give conclusion remarks to all the attendees about your presentation today?
Mm-hmm. Yeah, I mean, to conclude, I think what I presented is I think a big like a wealth of tools and content that we have and that we're going to open freely, which comes more from the non-formal approach of teaching, of teaching mathematics. Non-formal in the sense that it's not the classical way of doing formal calculations, tests, worksheets, but it's a more self-discovery approach. And I see a lot of potential in combining the formal and the non-formal learning, and maybe now having AI as a very important technology that for the whole society, for students, for everybody, just to get more of an idea and unveiling, I would say, this kind of the magic of neural networks, for example, in a way that you understand, okay, this is just a family of functions. It's just a few numbers that are changing. It's not, there's no intelligence in a way. I don't have to be afraid of numbers. Maybe I have to, but it's something that I know. It's like there's numbers changing. Come on, why should I be afraid of this? So I think in this sense, it's very important to introduce it in a way outside the school context, inside the school context. But it's a technology that will govern us in a way, and it's becoming more and more strong. So and it's too like it's explainable. So why not explain it, and why not trying to understand it? So I hope that we can open the doors now and have a lot of ideas how to include it. Maybe have curricula in different languages and build up something that the mathematics teaching world can use. And I'm very curious to collect, maybe if you have any ideas already or now, I will look at the previous keynote talk. So we collect the material that we have and maybe we share it. I'm a very strong advocate of open resources. So I would do it all openly, and then we can see if we can, I don't know, add AI to mathematics. And it is mathematics. It's also computer science. It's also many subjects. So that's interesting. We have some AI in music, for example. You could also add AI into the music course. And I think that's also nice to connect the sciences a bit. And then you see some computer science in music, but it's music. So maybe also to look at it from a broader approach. So of course it's mathematics, there's many things in science, but it's also much more, and it's very, very important.
Okay, thank you so much, Dr. Andreas, for a very, very interesting presentation today. Now, please give big applause to Dr. Andreas. Okay, thank you so much. And I also would like to thank to Dr. Christoph Benefesi, the one who connect me with Dr. Andreas, of course, so that all of us can learn from him today. Now, Ms. Lely, I think I have to give back the time to you.
Okay, thank you, Dr. Farida. Wow, wonderful presentations, ladies and gentlemen. Please give a round big applause to Dr. Andreas Matt and Dr. Farida for the very wonderful sessions. Once again, thank you very much, Dr. Andreas Matt, with your interesting topic, and hope to see you on the other Sikkim Talks. And Dr. Farida, once again, thank you for leading the sessions very nice. By the end of their sessions, it marks our webinar is come to the end. Before I close this webinar, I have several announcements for you, dear participants. The e-certificate will only be given to those who are eligible and will send to your email. Kindly check within a week ahead. And kindly fill the evaluation form of this webinar to make some improvement for CKIM in the next webinar. And don't forget to follow CKIM's social media, Instagram and Facebook for always being updated to CKIM's interesting yet challenging program. And thank you very much for our participants who joined the giveaways, and we will announce the winner soon on Instagram page. Once again, let me conclude by saying thank you to all prominent keynote speakers, Professor Ara Munajam from the Institute of Mathematical Science, India, Ms. Janice Jin from Weidong Cloud Education Group, China, and Dr. Andreas Matt from the non-profit organizations Imaginary Germany. Thank you very much for taking the effort to sharing with us today. And also thank you to all notable moderators, Dr. Ingriani Lim from Webras Indonesia, Dr. Mariam Othman from Simio-Rexam Malaysia, and Dr. Farida Nur Hasana from SIKIM Indonesia. Thank you very much for facilitating the keynote speakers today. On behalf of the organizing team, I'm Lelidian Puspita, would like to thank you for joining our first webinar. Hope to see you at the next international webinar. Stay happy and stay healthy, everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Recording stopped.